Looked like the music didn't finish there. Not sure what was going on with that. Hello, everyone. We are going to be doing more schematic stuff. Yay. No, I'm actually excited about this. I did a lot of work on it last night. I mentioned that I was going to just keep on going, so I did. Also, you can hear me, right? I see view meter bouncing around. Just wanting to make sure, because I messed around with a bunch of audio stuff today, and there's some things going on that are different and concerning, and, well, I will get into this. Yeah, I'm audible? Okay. So, yeah, the deck talk is active right now, but you might notice that it's a lot more silent. There's no whine sound. So, there's the USB serial cable that I was using with the deck talk. This was just one of the problems. I have Rafi55. Hello, since it's first time chatting. Sounds good. That's good to know. Temper your excitement on more schematics. Yeah. Well, I am excited because I think today might actually be.
Let's go end of line. End of line.
So, oh, that's a good reference, Digital Ice Age. Yeah, so you may have heard that weird sound at the beginning there. So here is the serial cable that I'm currently connected to the deck talk with. And I'm going to give you, nope, not that yet. Why did, oh, whoa, okay, hold on, I know what's going on. There we go. So this is the cable that I made, all right. Deck talk is quiet, I can fix that. All right, we'll try that again here. So, I disconnected the grounds. Because when I connect the grounds, we get horrible whining sounds. So, I've just disconnected them entirely. Technically, it's all at the same ground potential already because the audio from the mixer is going directly into the computer, so the audio ground is the same. Mic sounds fine, but a bit blown out. I can turn it down slightly. So, yeah, I just disconnected the grounds on the serial connection because I noticed if I unplugged the serial cable, it stopped whining. The only thing is now, though, as you may have heard, when Dogface did the message there, which, by the way, thank you for the 100 bits, you can now hear the serial transmission. So, I don't know what's up with that, but yeah, you can hear the serial data be sent as it starts talking, which is super weird. So, yeah, I don't know. Is the Elmrook marking on the CD drive painted? It's painted on, but Dan Org, thank you for the Prime sub and for the 4th month. Here's the thing. That is just painted on. It's flat. I could remove that. Up here, though, there is stuff etched into the top. That's never coming off. That is just cut into the plastic. So, yeah, there's really no point in trying to get off the paint because the top is permanently carved. Yeah. I mean, it's annoying from a, preservationist point of view, but from a provenance point of view, it's all right. I don't mind that. Like my my Sony Sobox ICC 1600 has Mountain Bell asset numbers etched into it, which is kind of cool because that's the only place I could afford something like that. This kind of makes sense. A school is like one of the primary use cases for a CD drive in 1986, which is when this one was bought. So it kind of makes sense it would go to someone like that. So I'm annoyed, but I'm not disappointed. So I'll phrase it like that. So yeah, it tells a story. That's a really good way of thinking about it. Raymond, him. Yeah. Elmbrick logo looks cool. It doesn't look bad on it, at least. I will admit that it doesn't seem bad. So I think maybe LN is reversed somewhere. Don't know if it's possible in the US, but in the EU sometimes helps rotating a power pack 180 degrees. Ooh, that's an interesting thought. I could try and do that. Audio out of sync? What? How is that even possible? Are you sure? Can anyone else confirm audio is out of sync? It's fine? Okay. No sync issues? All right, because it's all hardware. It's not like a USB mic or weird video stuff going on. So, okay. Audio isolator for the talk thingy. Well, the thing is, the sound is introduced by the serial cable. That's the thing.
Douglas McDodgerson says CHER 100 audio is fine here. End of line.
Awesome. Thank you for the 100 bits. Okay, so it all looks good. All right. Well, we should probably get started on this stuff. Again, digital ice age at 160p. I think the sync would actually be better because you're less likely to have data overload. Volume is much better now in the deck talk. Excellent. Cool. It's hard for me to tell because I have 3 volume knobs I'm adjusting for it. I have the slider that only goes to the mixed output to the computer, and then I have the monitor knob, which is how loud the volume is that's sent to the speakers, which it can overpower, send out a voltage that's too high for the input. And then I have the volume knob on the speakers, so they got a lot of things managed. So it's using ground for the audio, might want an opto isolator for the serial. Yeah, that I could actually see being a really good idea. You know what? I super like that. I don't know how I will then power the opto isolator on the serial side, other than with like a battery, but I really don't like that idea. But maybe that's what it's going to take. I don't know. So, yeah. But, you can... Yeah, so I don't know. I'll figure it out. There's a couple of different options. An audio isolator type thing is basically a transformer, right? Like, that's a thing, because I'm wondering if maybe that could work. So, I don't know. It's really strange. But this works for now, and it is grounded just through the audio cable going to the computer, and that's the most important ground level. So, there is that. It's a 1-to-1 transformer. That makes sense. Yeah, that totally makes sense. So, all right, I have a couple of things about the schematic stuff to go over, so let's work on that. Get old-fashioned linear power brick for the deck talk. Yes, I do need to do that. It's got that stupid big connector. That's the only problem. So I should probably order a bunch of those connectors and then make some adapter cables, because then I could definitely just use the linear power supply I already have. I could try and connect it to my BK Precision bench power supply that's linear, but that's like a whole other ball of wax to get into that I don't particularly want to. So, yeah. All right, let's go ahead and switch to this camera. Actually, no, it's be that, and then capture, boom. All right, there's some cool stuff happening over here. So, first off, check this out. I'm gonna move the window now. Ah, yeah, look at that. Look at how low latency that is. What? I'm using NDI now. It's working perfectly. So we have super low latency for the video capture now over the network. I am connected over Ethernet. I might be able to do this over Wi-Fi. I probably can. So in the future, this might be even easier, like literally just walk around with the laptop and have wireless low latency video capture. That's gonna be bananas, but it should be possible. Let's see, I had a ground loop problem when charging my phone in my car while having connected an aux cable on the radio. Cut a cable down and soldered a couple transformers from old 56K modems I had stereo. Interesting. So there are two DEC PDP-8s on eBay at the moment, with one being quite affordable if you want a competitor for your Novas. Oh no. Oh no. Dude, oh no. I don't. Oh no. Let's see. How bad am I gonna be into this? Probably not gonna happen though. So let's just see. PDP-8. Actually, probably no minus. Oh, that's not happening. Is that the other one? No, that just looks like the back plane. That's garbage, unfortunately. Yeah, I'd probably just buy a standalone audio transformer. There's a lot more PDP stuff than there is data general stuff, but that kind of makes sense. Yeah, that's just the back plane. So that really doesn't do anything at all. That's just a nightmare. That's a mouse pad? What? That is super anachronistic. Anyway, that looks like too rich for my blood right now. Yeah, so we got some stuff going on. I'll get into that in a moment. I ended up... Oh yeah, so a couple of things here. Another thing is if I, let's do this over here. If I take the windows down, you'll see they only show up where they actually show up. I am color keying to wallpaper color, so I can actually like have stuff go away and not cover. So if I like minimize this, now you can see that whole screen, which is really nice. So that's an option now if I want to do stuff. Some other things. I did a lot of cleanup on the schematic last night. It probably isn't going to look like it too much because then I went and did more work. But I now have a bus for the lines over here. I think they're all correct because it turns out that it's like this is backwards, this is descending, this is ascending. So yeah, well actually I'll strike that, reverse it. But yeah, so that's a thing. I've started to get data out to the buffers and onto the internal drive connector, which I forgot to put on before. So that's happening there. So far it looks like the pinout on here kind of matches the pinout for this connector down here, which is interesting because command is RX. No, it's TX, which kind of makes sense if you have like a really dumbed down protocol. So it's TX for command, and then response is obviously RX, although I think I haven't got to that yet. But attention is another thing, which is weird. I didn't pay attention to where that goes. Let's do this. It goes to DSR. Is that data send ready? I forget what that is, but that could make sense for attention actually. So yeah, it's interesting. But yeah, so we have some stuff going on, but yeah, just look at how nice and low latency that is. And I've been running it for now like a half an hour. It's drifted maybe a quarter of a second. So we should be super good. I don't know what, how long it's gonna take for it to like really drift, or if it even will. Being a fancy thing, it may not. NDI is really nice tools. It's a little some and half dozen the other. The thing is that getting it working was a huge pain because you can't just give it an IP address. It's just, yeah. one of my mods on my Discord server, Nev, described it as a black box protocol, which is kind of exactly what it is. So it's really frustrating. Anyway, I learned a bunch of stuff last night, like the hotkey for highlighting nets. That's super duper handy for just going through, figuring stuff out. Like I said, I moved a bunch of stuff around. So over here we have the 7108 logic block thingamajigs with one of the 7106s. So I moved those around because that's where it goes. That's really how it makes sense. Horde is set up. Yes, it absolutely is. You're seeing background traces in I'm seeing the background shapes in the blue bus trace. Are you really? Oh, it's pretty close, isn't it? Maybe? I don't know. Yeah, it is super close. Oh, let's see. Here's one coming in. See if that goes. It's visible. Well, the yellow might be slightly more visible. I don't know. Maybe it's not too bad. Anyway, see. That's really close to the color that I'm actually using for the background. It's a darker blue because I wanted it to, if there was like a shadow effect that was being applied to the carpet backdrop, then it would look okay, and a dark blue would do that. All right, Felix Band Python calculator. Again, this is a much more likely time for me to use that without thinking about it. So yeah. Anyway, let me go ahead and catch you guys up on where we are at. So let me move this out of the way here. So the 595s are all done. As much as I say that, but then I'll figure out there's like, oh, there's another trace that's running under it that actually connects to something. So I think they're all done. All right. The 7111 is done and 7109 is done. I'd started on 7110, but it's one of those pesky chips that's got passives associated with it, and I have been avoiding getting into that, partially because I want to not forget any passives, and if I start getting into them, then I'm likely to start forgetting them. So yeah, I'm thinking though now the crystal should be the next thing. Starting from the crystal, what I should do is I should look up either the 8251 or maybe just like 5 megahertz crystal in general and try and figure out what all is actually connected to it, because we have the caps up here, which we don't know the value of because they're not printed on capacitors. It's just how it is. We do have a resistor that we know what it is, but I would like to find a application example for the clock so that we can have a rough concept of what those values might be and then lay this out. I mean, it's really easy to figure out where this goes. I mean, this thing, it just goes from boop on drafting here. It's just going from right here to there to there to there, easy, and then it goes boom, boom, done. So it's really simple to figure out how it's wired up. The real challenge comes in figuring out what all is there. Crystal is going to the HC. Yeah, it's going to this thing, which, as you mentioned, cap crystals is crystal dependent. Yeah, that's why I want to look up like a 4.9 megahertz crystal or a 5 megahertz crystal with a serial schematic to see if I can find something that looks like this. You know, it might even be worth looking at the serial cards I have to see if I can find one. I don't know. Those are probably variable, so that wouldn't be that useful. It would need to be a client device. So, yeah. But one of the things is coming off of this chip, I think. What is this? So this is, we're going to pin 14, 13, 12, pin 12 on 1710 here. That is the main R clock for the shift registers. So this is doing some clocky type stuff. It'll depend on the loading of the crystal. I wouldn't worry about it until sourcing parts. Wait, so you're saying the actual crystal? Oh, okay. All right, so between Raymond and Helicroft, now I get it. Okay, that's good to know. So I'm gonna have to look at the data sheet for the crystal, not for an application. Okay, that's good. Well, it'd be the application for the crystal. All right. The resistor value on the back, would that be specific to this application, or is that also going to be part of the crystal? Because now we're definitely into things that I'm not familiar with. It's weird that there's a resistor across it, but yeah. I wonder where that thing is, too. It wouldn't make sense for it to be an inductor, but resistor is general for the circuit. Okay. It's black like an inductor, but it's across the power rails, so it's probably just a capacitor. Probably a big capacitor. Might be early tantalum, I don't know. Yeah, I might have to... I'll ask the person who has the board if they have the capability of measuring little tiny capacitors like this. Probably not. For the other ones, because how many capacitors are there on the back? Yeah, so 1, 2, 3. Oh, that one is black. A cap there. That's easy. 3, 4, 5, 6. Well, no, remove those. 4 down there. 5, 6. So, well, that's power decoupling, power decoupling, power decoupling, power decoupling. That one's weird. Oh, hello. Did I see that? Yeah, no, I did actually get that on the back before. I'm pretty sure this is power decoupling. The only thing is that I don't understand why they took the way they did, because the trace, the via goes through to here, and then it comes over to that pin. So, like, that's ground, and that's connected to right there. So they go to ground right there, but this ground trace should probably... Oh, wait, no, I know exactly why. That's the weird one. What did I just do? Colors, hold on. Oh, no. I hate how easy it is to change the layout. Can I reset the layout? Great. Well, I just ruined the drawing tools. Somehow. Oh, there we go. Anyway, back to this. This is the chip that's... No, it's not the weird chip. Yeah, so I have no idea why they couldn't go to ground right here. That's the thing. Brown caps are... Yeah, they're almost 100%. 100 nanofarad. Green caps, yeah, I don't know what the green caps are. Don't worry about cap values, we can guess them. Okay. Yeah, I was figuring 100 nanofarad for the brown ones, but I didn't know about the... I usually see them as tan. They might be green because the image is washed out, but yeah. See, caps are only 47 nanofarad or 100 nanofarad, yeah. But anyway, this one weirds me out. Why is it going over there rather than just straight through the ground trace? I don't see... Oh, no, that one... That might head it off. Because that's on the top side. I don't know. Well, we'll figure it out. Let's go ahead and continue. Wait, did I not finish this chip? Oh, maybe we should do that one next. What is that? That is 08? Probably not that many left here. 1. There is 1 left. Yeah, let's just go ahead and do that. Okay, so pin 9. Oh, and pin 13? Wait, no, I have pin 13 connected. What? Oh, wait, no, that's not for this part. Okay. That's why I didn't want to start making the schematic look pretty, but yeah, no, that's fine. Okay, so pin 13 should be over here. Where'd that end up? Seven. Oh, no. 8, but I don't see pin 13. Also, I can get rid of that. Oh, there's pin 13. I'm an idiot. All right, so we got pin 6, pin 13, and pin 9 to do over here. Yep. All right. Let's rock and roll. Oh, pin 6 is a resistor. Cool. Let's see. To avoid getting up with a sore back in a couple hours, probably should be getting up and stretching periodically. Yeah, you'd think that. Usually what I do is I just switch between leaning forward and leaning back in the chair, so I'll probably do that periodically. I'm actually feeling like leaning back right now. So, let's go ahead and do this. Hide all of that. Let's look at the back. None of those go anywhere. They jump over that resistor. Oh, I don't like that that resistor goes to something. Is that probably just going to ground? I hope. Oh, I don't like that. All right. So 6. Why would they tie an output to ground? That does not make sense. Great. Where does that go? So you would think it, but it's an output though? A 1K? I mean, that means it's got to go somewhere though. That's the problem. What was pin 2? I don't think it has a trace going to it. So there's just the backside. We have the test point, and it goes to the resistor. So there's 2. 2 goes over to 13, which this is not that. 13 is ground. I do know that. So this is the, let's bring that back. 32. Or not pin 13, pin 7. So pin 7 is a ground, so that one's ground. So that just connects right there. I don't know why, but I always like looking at them like this. Why did we determine that pin 2 goes to there? Signal they use during test? Maybe. I could see that. But I don't like the via. Oh, well, if it's pulled down, that could make sense. Pin has the cap. Pin 2 has the cap on it. Pin 2 has the cap that just takes a circuitous route to ground. Yeah, this is pin 2 up. Right. Hold on. So 2. And 2 goes through the cap, down, back, down to pin 7, which is ground. The only reason I'm saying that this is pulled down is because we have the ground rail that goes up like that, but that's kind of off-center. They don't usually do that for those. They're usually pretty, like, dead on there. So yeah, we can see those ones. They're right smack dab in the middle. That's a little weird. I could see that, Hellencroft, but then where does this trace go? This trace could go to that instead. What is pin 8, 9 on 08? 9. 9 is an input. Oh, KiCad's over it. All right, there. It's over it a lot. Hold on. I can do this now. Oh, now I need to get rid of that. That'll help. So we could say this trace is wrong. Rebuild that, that, and that. And then what we say is this connects over here. And then this comes up to there. That's an option. It is also, though, entirely possible that the yellow trace there is fine. No, it can't be. Because I was going to say if this connects... It might have to be that, actually. Is that going through the ground? Well, that's the thing, Just. I think the ground trace actually ends right here. So I think it goes up to that point and then stops. Because this capacitor goes all the way back around to that pin just to get to ground. So that makes me think that the ground trace does not continue up. So it is possible. Yeah, so this can't go to that because it would cross over that trace, and there's no trace on the back. So this is 08. If we look at the back side, there's that. Pin 2, unknown. Pin 6 goes to that which we can't see the other side of. So it definitely, obviously doesn't go through to that one on the back. We have no idea what that does, but there'd be no reason they wouldn't just stay on the back side to go to any of those pins. So it could be that. Pin 9 first, yeah. So if I, again, if I get rid of this, all right, pin 9, oh wait, 8, 9. So, well, 9, we don't have any idea. That's an input. So 9 is over here. It is an input on 8. So this is 12. 12, pin 6. 12 is up here. 6 is Q inverted. So that's an output. It's on the 74. Let's look at that. Maybe. What? Did I hide the... Did I close the web browser? Oh, hold on a moment. Yeah, I think I did. Idiot. Alright. Code. On the scan one, not the photo, I can check that in a moment here. Oh, man. Let's see. Wait, I didn't bring it over. Image ref, this. Gonna play a ball going view. Okay. So it would be here. I think it's going to be the photo. You can potentially see that because this, you can't really see much. Yeah. So that would be this one then. It's really hard to tell anything. 1646. All right, I'll take a look at that. Anyway, that's the 74. Up there, yeah, 74. So, boom. Yeah, that's super hard to see. I can't really definitively say much. They're component level streaming. Yeah, kinda. So like one of the things that I could try and do is exaggerate the differences. So we go colors, levels. We're gonna active layer is not visible. Oh, hold on. There. Colors. Hold on. Colors, levels. What? Why is it not opening? It's not locked. Okay. Colors. Levels. Is this the thing that I accidentally broke at the beginning? Color balance. No, that pops up. Oh, is it under this? Hold on. Colors. Levels. Alright, found it. No, it wasn't read-only. I have the chat set to always be on top. That was my fault. Okay, so I can bring that up. Try not hide anything. Bring the black down. Then I can try and adjust the gamma stretch point to exaggerate it. So yeah, we can very clearly see this trace wanders around there, and then confirm that. So we can see that, but the shadow from the chips is really, really strong. If anything, I'm inclined to say the ground actually continues to at least right there, because it's lighter in the middle there. It's really, really hard to tell, though. Yeah, I don't think we're, unfortunately, not going to get anything definitive out of that. Although, I do know this chip it ends, because if we look here, we can see it just goes straight into that pin. So it definitely 100% ends there. And this chip isn't dark on the bottom. This one is. So it might continue up to there. Although that's all dark, but then there's a whole bunch of stuff around there, so... What does that one do? One goes to there, and then it would make sense for it to end right there if it's not needed. Nothing else jumps over to get ground. So maybe it does continue, and then that's just a really badly placed via. My current inclination is to ground that. Ground that and mark that as the least sure thing in the whole schematic. And then ask them to see if the resistor's end here connects to ground, or if it connects to pin 2 or pin 6, maybe. Wow. When I go to make the PCB, I'm going to make a much more definitive list of all the things that I would like them to check. And then before I have the PCBs manufactured, I'll give them some time to do that. Because once I'm starting on laying out the traces, I am going to be actually tracing the traces, trying to make them match as close as possible, and it'll be super obvious which ones are really difficult to do again there. So I'll have another reminder of which ones were guesses. So, but yeah, I'm inclined to say it doesn't explain that though. Then there's no reason at all that that wouldn't just go back. Unless they needed to connect to that on the top side. This is slightly bright there. This is like so bad. Oh well, let's ground that, move on, call that close enough.
FILYX 20 SIs MRDESTRUCTOID 100 ground control to Major Tom, ground control to Major Tom. Take your protein pills and put your helmet on, ground control. End of line.
That one worked a little okay. It really didn't like the robot emote. The static at the beginning when it's receiving the stuff is bad. I might actually try and put some kind of delay at the beginning of the string now. Although, maybe I'll just get the isolators and flash what makes it. Yeah, maybe the audio isolators will be the way to go. Alright, so we're grounding that. Yeah. So that's pin 6. We're just gonna ground the output. Oh, I super don't like that. Add resistor. This makes no sense. Absolutely makes no sense at all. I'm going to label this probably not.
FILYX 20 SIs MRDESTRUCTOID 100. Then how about the classics then? Ayu, John Madden, John Madden, John Madden. End of line.
Thank you for the 200 bits, by the way. Yeah, I think that's the first really unanswerable thing. Because it makes sense for it to be grounded, but the via location doesn't make sense. It doesn't matter from a production standpoint where it is in the trace. It's just they've always been in the center of the traces everywhere they've been there. That one would be really sloppy. We also don't know that the trace doesn't move up or have like a thin trace that goes over to it. It may not connect there. It might be a really thin one that goes like this over back to there. We can see down here, actually, if I remove the drawing layer, when it connects to that, it is thin. So it would make sense for them to have ended the rail and then have a little thin one that goes up there. So it could be that. We just don't know. Oh, then we have one other problem, though. What does this connect to? It could be this. Those are perfectly in line. What is that, again? It goes to pin 13 on 12. So that's this. So output going to pin 6. One moment. Output going to pin 6 input could make sense. Wait, no, pin 9 input. And then it goes to pin 6 over here. So it would be this. Well, pin 6 on this one. Sorry. Yeah, I meant pin 9 here. I was wrong. So pin 9 on the 8, which is this. Down, yeah, that's input. Then pin 6 on 12 over here, if I just finish the connection, boom, is an input. So it could be that. That could explain it. So if I run this back here, pin 11 of the gate or the flip-flop can't be right. So you are keeping in mind this is no longer this component. This is not that, because I changed the schematic. That one does not go to this part. This is 6, so it's down somewhere. Where is it? This is why I didn't want to optimize the schematic at first, but then it made more sense. You're looking at the schematic now? Okay, so hold on. Pin 11, I don't know what the part is itself. I'm going to need the ref des, sorry. I do not know what these chips actually are. Okay, so this doesn't make sense. That's going down to here, 8, 9, 10, 11. Okay, 10, 11 of the OR gate. The output of the flip-flop can't be right. We have 2 output connected now. So why is that not allowed to be 2 outputs? Well, 3 outputs. 8, 9, 10, 11. So if that's output, that makes sense to me. It goes up to around there to pin 13 on this, which looks like an input to me. That's the 74, 13 input. 6 is an output. Well, I mean, but it could output to the input. 13, yeah, 13 is an input. So, yeah, that's an output to an output. Could it just be both of these want to reset that? I don't know. Oh, Helencroft, I didn't bring this up to you. You cannot have 2 outputs connected. They will fight and fry something. Well, okay, so I was bringing this up in the Discord server. I have a trace that connects to an output of whatever the 125 is here to the bus of the 595 data. So that's 2 outputs. That is a big short circuit. Oh, so what about this one then? Is that one dumb too? Is that not possible? That's down here. Where is it? This. I'm going to bring up purple. .125 is a gate output enable that can be connected to a bus. Output enable. Oh, well, all right. That one still really weirds me out because it's just 1. Okay, so that doesn't make sense. So it can't be that, I guess. Oh, hold on here. Okay, so let's undo those 2 things. And everything over here. Okay. Pin 9 on 08. 08. Pin 9. Boom. Highlight. definitely 100% connects to pin 6 on 12. 100% unquestionable, it goes to that. It could potentially, hold on. Okay, that's output there and then an input there, but we have this via. So the via needs to go somewhere. Hello, Lucifer Sam. The via has to go somewhere. So the via could go to pin 2, which is another input. Or it could go to whatever pin 2 is connected to, which is another input. That I have no idea what a vector voltmeter is. We don't have an input to pin 2 to pin 13 here, wherever that goes. Yeah, so hold on, but that would mean pin 2 wouldn't connect to 13, and then 13 would be a mystery. So pin 9, pin 6, way over here. Okay, so here's a potential alternative. All right, so 9 to 6 is definite. 2 to 13 on that is okay. Let me do this. Not that. We do instead that. So go there. This goes over there. That just minds its own business up there. And that connects everything. So this would be pin 13 to 6. That's an output to an input through a resistor. Delete that. And then, no, that goes to pin 2. And then pin 9, boom, to, that's pin 13 on there, which is an input to an output to 2 inputs. What do we think about that? You can only see top half of the board view. What do you mean top half of the board view? Yeah. Okay, so like that. Let me get this out of here. So have the pin 13, that's an input on the schematic over here. Whatever you're doing there, GIMP, I don't like it. Over here, pin 13, which is down here. This is pin 13. Connects to pin 9 here. Pin 6, output to resistor. Pin 2, cap to ground is RC timing circuit. Yeah, that's what I'm thinking. So pin 2 would go to the resistor over here. before resistor goes to ground. And then cap pin 2 to ground. I'll just go ahead and add the cap. So it'd be like that. Other side of resistor? It is that, wait. It is on the data side, not the ground side. Oh, wait, yeah, no, I see what you mean. The resistor doesn't go to ground anymore. That's right. So, blap, blap. Boom. Okay. Steven Price 99. Hello, since it's your first time chatting. So, vector voltmeter can measure the phase difference between different supply voltages. Ooh, that's interesting. Okay, so resistor goes to pin 2 to that. I don't know why ground got deleted. Let's add that back. Cap to ground. That kind of checks out. Then pin 6, wherever that is. Oh, that, no, wait. Pin 9 connects to pin 13. Or no, pin... Yeah, 9 connects to the input on reset on there through the other buffer type thing, which that reset is dependent on. Okay, so that's weird. That right? Oh, why does that go to so many places? I don't like that. That feels like something got connected when it shouldn't. Also, pin 2 of 7112. What about pin 2? Yes, yeah, I do see that. Okay, yeah. Where is 7112? So it would be it's pin 6 to that. Where does that go? I want to double check that that's not a complete nightmare. So pin 1 here. Oh yeah, no, that one's an awful mess. Oh, I'm very tired of it, of its Lars, but it still has to be done. So my exhaustion and frustration with it does not override the it getting done factor. Why does my computer make now? Oh, that's not good. Mouse battery's almost dead. I've not had that happen at the office yet. The cable is not here. Uh-oh. It does not last long after that trips. It's a weird connector shape housing. That might be difficult to do. Those are C's. That's empty. That's a C. Do I not have any micro USB cables in my bag? Uh-oh. Well, I have some here. All right, I'm gonna go grab a micro USB cable. I will be right back. Whap. It's got to be one with a relatively small shroud. That one might work. And it's not precious. If it doesn't, I can shave it. Oh. Be glad it's not one of those stupid Apple ones with a power connector on the underside. Yeah, really. It would just literally not happen. Because I would never use one of those. Alright. Will it fit? No. Because they're jerks. Seriously? I might be able to make it fit. Give me a moment. I just have to cut a groove in it. For giggles. Here you go. I'm gonna try and do this. Use my vise here to hold it so I don't cut up my fingers. So I need to put a slot in the side so that the stupid groove that aligns the cable can fit somewhere. This is totally what I want to be doing right now, mouse. I wasn't doing work or anything. I could just put some non-rechargeable batteries in it as well. I don't know if that's enough groove, but we'll try that on that side. Cut another one on this side. I might go slightly larger. It looks like I had more space to work with. Come on. I'll go see if that was enough material removed now. Remove all the plastic. I don't really want to. I think the grooves are in the right place, but they need to be way deeper. And the smaller one needs to go slightly more up. Oh, hopefully that white doesn't mean anything significant. Oh, whatever. If it's thinner at the back, that'll mean it just sticks in more. I think this will do it. Then I'm going to have a backup cable for the mouse, so that'll be kind of nice. Man, I don't know if that thing will ever come out. That is not easy to... Oh. I gotta shave the corners. I'm getting close to remove all the plastic here. These need to not exist. Give me the red light of oh no's. Ah. Ha-ha! Snapped in. And power. There we go. All better. Crisis averted. Okay, so yeah, I think we're going to that. Anyway, I was going to kind of show you guys this one too. This trace is really dumb over here. This one connects on the top side to, excuse me, that pin, and then it also connects on the bottom side to that pin, and they both go completely different places. So that's an instance where they're using the pin as like a routing point. They also have one down here that is an utter nightmare. Look at this thing. There are 3 different traces coming out of that pin, and honestly I wouldn't be surprised that one's connected to the other one. Because, yeah, there's a couple of nets on here that are just, wow. So that's 709, pin 9. Let's find that one. 709. That's this one, pin 9. Boom. I think this might be the main serial. No, that's DSR. So, yeah, that thing goes like a whole bunch of different places. KiCad over it again? Oh, sorry. How has this not been a problem yet? Let me try this. I'm going to go over to OBS, and I'm going to... hesitant to shrink it. Maybe just move the left monitor over a bit, but then it's going to be under the chat. If I cropped that side, why did I do that? Wow, I cropped a lot. Here, I'll crop that much. So that goes to right there. All right, so we're going to try that. Move GIMP to the right. Yeah, I did. Hold on, that monitor, that fills that area, right? Yeah. So it fills that. Actually, I can move this to the right a bit like that, too. That'll help. All right, let's go with that. It's really hard to do a multi-monitor one. Stream type layout. So, all right, how about that? That's probably a lot better. Yeah, you can't see the histogram on the right, but that's completely fine. That'll probably work now. So I can make that full screen. And then as long as I have things roughly in the center, you can see all of it. All right. 2 streams for 2 screens. Yeah, really. Could almost do that. What was I doing? Oh yeah, that net, and then the serial net. That one goes everywhere. There's 2 of them, 3 of them. Yeah, so that and that. Oh yeah, so one of the things I think I determined, one of the 595s is an input and one of them is an output. So this one goes to pin 3, which is response. No, that is data. So that's data back from the drive, I think. And then the other one goes over here to this one at the bottom. And I think that, yeah, that goes to attention. So I think that might be for the drive saying it's ready. I don't know, but it's weird. I don't fully understand that. 595 serial to parallel. Yeah, I do know that. But it's weird. I don't know. I'm really afraid this is just gonna not work at all. Anyway, we'll find out later. What am I doing? I was looking at this area up here. I think I'm gonna go with all that garbage. Let me undo all that purple and kind of make that a little more solid here. So we're gonna go with all yellow. Okay, so here to there, and then here to there. That's my best guess. All right. And we got pin 13 down here that we still need to connect, and then this little dealy-doo there. So strange why resistor and cap are not connected on the bottom. Well, there's a bunch of traces in between them. Like that. If that's what you mean. I don't think they could have fit 3 traces in between. Oh yeah, no problem. You know, it almost looks like they might have tried. Like they squished in those traces as much as they could, like they were going to try and bridge the cap over that. That might have been an earlier design attempt. Because this seems a little excessively squished in, and that one really does. They don't need to do that, I think. Like, if they left this straight, it might actually be farther away from that via than it is snugged up to that trace right there. Like, I'm actually curious here. If I did that straight across, right, oh my gosh, right there. Yeah, there's way more space between that trace and the via between that one there. Yeah, so they may have actually tried to do that. All right, so we're going with that. All right, this one. On green, boom, 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 boom. Goes to 7, 6, 5 on that. 5 is Q. Okay, so it's that's ugly. You know what? Should do. Do I have room for that to go over? I do. I'm gonna move that way over. Move this out 1 and 1. Have. Is there any reason that has to be there? I don't think so. There. Now that's cleaner. Okay. See, so this chip done now. Yeah, that one is done. Yes, it is. Okay, so we can mark that one finished. And then I think we need to move on to that one. Boom. Because we definitely need to mark this 6. Why is this not 6 to 2? Okay, so 6, boom, to 2. Oh, we already did that one. Okay, well, that's good to know. All right, well, 1, 2, 3, 4 goes over to mystery. Oh, that's grounded. No, that's tied high. Okay, so these 4 and 10, 11, 14, 13, 12, 11. So 4 and, ooh, that one's gross. One moment here. Let's grab that. Not that, not that. Yes, that, and that, and that. All right, 4 and 11 are tied high. So I'll grab a VCC. Boom. Because that top rail is VCC. Yeah. 4 to VCC makes sense. 4 is C, whatever that is. I don't know what that one is. But we can see that it also connects through to that, I believe. Ooh, no. 11, it does not connect to 11. No, that's the flux making my life complicated. That goes there. Wow, there's like 3 pixels that I can see for that. Jeez. I think it doesn't connect. Wow, I hate that. Okay, so we'll say it does not connect to 11. What did I do? It's too easy to click in the wrong program. So not connected to 11, just VCC. 11 connects to mystery via, oh, that probably goes down. That would make a ton of sense. So, oh no, I don't know. Yeah. Alright, so 7 is probably ground. So there's a 74. Probably ground, but I'll just double check. Oh, that's already what I got open, so it's almost certainly ground. Ground, alright. Boom, boom. Is this one of those stupid ones that doesn't have? Yeah, or maybe it's down here already. 12. 12, okay, there it is, already connected. Okay. All 74X corners are grounded VCC. Alright, that makes sense. In that case, I can mark that as well. Okay, this one is pin 8, which is the inverted one. And I think on something else we determined that that may not be connected. Is that? 74. This is a 74. So yeah, I think we're going with no connect on that. And I'm going to go ahead and change that over to the more contemporary blue X. That's meant for cool people. 74. Yep. All right, and then we're going to paste another one of these. Pop it right there. Boom. All right. One or both of the Qs are needed. Yes, but I think we determined that 8 in particular, this is more likely to be no connect, because we did that over here. I didn't put the no connect, it seems. Let me grab one of those, copy, paste. That was for 13, which is, oh, hello, those are the 595s. That's not what I was looking at. Is it this? Yeah, and that is obstructed. That's 13, yeah. Having one of them not connected is fine, yeah. So the other Q is, what is it? 9. Actually, both have one connected. Okay, so we're good. So I can pop that. Boom. Done. 8, 9, 10. 10 is in that. Ooh. We have a... What? So these are two of the same logical element in one chip. 4 here had to run across to get VCC for that logical block. This one would not. So it would make sense if it operates similarly that it would just reach straight down to get VCC. What did we do on 13? That one we have it going somewhere else. I don't know if we can tell where that's going. I don't think we can. It could be no connect, and it could be... It's the startup value when it's reset, so high makes sense. We can go... I'll do this, and then mark it probably with context. Because I don't think we can determine that any other way. And I have a feeling we're going to mark pin 12 up there is high as well, because we did that down here. And I don't think we can see anything on 12 either. This does go all the way through, so it's either connected to that or nothing. So, anyway, pin 8, 9, 10, 11 connects to something down there, and that's going to be scary and long, and I need to delete that. So let's figure this one out. 11. All right, I'm going to start doing this too. I'm trying to, when I start a net on here, trying to highlight it so I keep track of it, because I like marks where I'm at. 12 maybe goes to 2. 12 to 2? Ooh, because of that weird bump? I don't... Oh, if it goes to 2 on the top side, we're super screwed. We have no way of knowing that. Oh, wait, it definitely can't... No, it can't possibly go to 2. The 5-volt rail goes clear through the chip, because this is the source of it. Yeah, no, that's not a problem. No, okay. I actually don't mind re-establishing that every now and then, just as a reminder, like, no, you're on the right track. So that one's probably tied high or not connected. I'm suspecting tied high, but let's work on 11 right now. Actually, you know what? We'll just do this. Copy, not cut. Paste. That's not what I want. I'll just yoink. Nope. There we go. And then, oh, you know what? Actually, hold on. Yoink. And then I'll just mark that for both of them. Boom. Okay. Now, let me move this in, that up, even though it's going to go down. Where's 12 going to the trace that runs between it and 13? Yeah, see, that I'm not sure about. I can look at the scan here. So pin, yeah, I don't think so. I think that's just the highlight from the flux. Let me look at the actual scan that's not the photo. Because this looks different. So it'd be up here. So yeah, I don't think that one goes there. So this is that, I think. We got 2 vias right next to each other. The stupid flipping everything around makes this really complicated. Yeah, okay. So, oh, hold on. Is that a connection? That is like 9 pixels to base that off of. I don't... No, that is it, though. But I don't think that's a connection, because here, it clearly does not go directly across. It almost looks like it could. Up there, you can't... Hold on. Where? Right here, it almost looks like there's some weird diagonal thing, but they've not done that on the schematic or the PCB anywhere, so I don't think that's it. And it doesn't look like it goes dead across. So I think we're good. I think we can skip that. This flux highlights, though, man, they really make it look like it connects sometimes. They must be doing some like weird lensing. Because when they connect, there was one that's connected. When they connect, the solder mask is like kind of lifted up. Solder mask highlight? Oh, you think that's solder mask, not flux? All right. It's a thick solder mask. There we go. Here's one that's connected. The solder mask is lifted up slightly, so it's silver off to the side. Instead of, yeah, so there we see it again, rather than just like it looks more green. So I think we're good. I think we're good. So I tied 12 high. All right, let's do 11. Actually, 11 may not be too bad. Hold on. So we go from here, shiny side of the hole. Yeah, so like the lip of it. Yeah. So there. Then we're gonna go from here to there, and then here to there. That's pin 2 of, is that 10? 10. Boom. So 10 is just over there. Ah, that's a real short run. Whee! Yoink. All right. That is, I think that's an input. I don't know what that weird triangle thing is. Probably means something. But that's an output, so I think we got it. And that's, is that chip done? I think that's it. Means clock input. Ah, well that would explain why it goes down to that chip then. Because that chip's all clocky business all the time. Left parts of symbols are usually inputs, right side are outputs. That does make sense. That's generally how all these are working too. That is actually something I knew at one point. I probably just forgot because I have not done this in a while. Boom. All right, chip done. We have 4, 5, 6 chips left. We are getting pretty close. That's why I think we might actually get to start on the PCB today, or at the very least, do some like logic checks. Although I think getting started on the PCB will reveal more logic issues than staring blindly at the schematic. So, unless someone has been turning the gates around. Yeah. Yeah, I'm thinking starting immediately on the PCB after the schematic is done is probably going to be the best way to reveal issues with the schematic, because I'll be laying out the traces and then seeing how the rat's nests don't make sense. For convention, shouldn't your gate symbols be rotated 90 degrees? I'm doing it based on how it kind of, I don't know. I don't really, maybe. The schematic has been a complete nightmare. I would almost be open to the concept of redoing the schematic entirely after this if I could have a rat's nest for it. But without a rat's nest for the schematic, I don't think I want to do that. So it's probably always just going to be hideous. Moving the gates on the schematic to functional blocks makes sense to search for faults. Oh, you mean have something like all of these be a box like that? Because that's what I wanted from the beginning, because it does make it easier to search, because I'm looking at chips that have pins in rows, and that's how that kind of thing is set up. This makes it really hard, especially when I start doing stuff like this to simplify the schematic, where it's now this one thing over there, but I don't know. Probably not worth redoing the schematic if it gets the job done. Yeah. It's just I would like this to be like the resource for this once I'm done, and this is awful. This is horrible. So the clock circuit, driver timing circuit, UART circuit, yes. And then the buffered output interface thing. No, as in group addressing logic together, shift register chain together, that sort of thing. Maybe. I already put the shift register stuff in a bus, so there is that. But, you know, there's like way more. You'd think like, oh, that's a bus there kind of looking thing. Not really. It just all happens to go up and down a bunch. As for public documenting, an iSchematic is better. Yeah, see, that's why I kind of want to do it. But I don't know. Rat's nest, or it's not going to happen, and I don't know that there is a rat's nest type thing in here. Oh, clicking on that might have been a bad idea. What is this? Oh, that's for doing subpages. Okay, fancy. All right, this chip, this one should be really easy, and there are no passives. So what do we got? This, that's a thing. Let's look at that thing. Where'd that go? Pin 4. So this is 15. Way up here. Pin 4 is one of them ones. Where does that go? Other than far. So no reason your schematic can't be the foundation for someone else to polish. True. I am the thing is that the device I'm working on here is so rare, no one else has one. So there's not a lot of community incentive to try and optimize it for reference. So yeah. All right, so that goes to pin 2. on 10. Wait, didn't I just connect something to pin 2 on 10? Pin 13. Ugh. Which is input. That makes sense because that's an output. Boom. 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 Alright. And didn't collide anything. Alright. Next. Pin that one. That's 5. No clue. Mike's sound changed. Oh, I bet the stupid RCA jack is loose. Sorry. Hold on. I'm gonna kind of mute it while I figure that out. Ugh. Ooh, that's there. Test, 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 test. Okay, how is that? Does that sound good? Noise floors through the roof. I don't know. The mixer doesn't show anything. No better. Still got the noise. All right. How about that? Did that solve it? Let's just do this for right now. Okay, so after I just did the thing, is it still bad? I see Gabbermax solved it. Cool, so the deck talk went gone. Went bad, somehow. All right. That's weird, because I'm not hearing it. Ooh, that was loud. Sorry about that one. Oh, yeah, it's how about now? Is it really bad now? Because I bet it's bad right now, if it's there. Yes, camera, that is, in fact, a CM-153. Camera, I'm right. It's good. Noise is back. Still noisy. All right. So...
Deck Talk Express is running. External power on.
I don't hear the noise. I don't understand. I didn't disconnect it though. I just turned down the mixer. I just put the slider down. I didn't actually change anything, and I'm not hearing the noise through the speakers, which I should, and I don't see it on the VU meters. How is it right now? All I did was restart the deck talk. I can only say I hear the noise if I crank the volume up. I like how I managed to fix the noise for just me. How is that possible? For giggles. That's way worse, right? Now, it's way worse. Okay, so that should be better. All right, so that was me connecting ground on the serial cable. So now, no ground on serial. And it's just connected like it was when I said it was better. So is this currently acceptable? That's the big thing. It's bearable now, but before the sound felt more stereo. Feels like you're on a mono mic or something. How does anything bad, like, how did that happen? I have no way of really monitoring this. Let me go try and grab headphones and plug them into the mixer and see if I can hear it. But since it's all live and hardware and there's no delays, it's really hard to get a feel for it. Where did I put the headphones? Uh-oh. Oh, there's the USB hub I was looking for. Headphones, headphones. Oh, there they are. They were hidden behind a bunch of stuff. All right. Okay. Test, 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 test. Okay. So, I can now hear the output. Yeah, I hear your noise. So the noise, yeah, there, it wasn't totally gone. Now it's totally gone. So I can plug that in. Yeah, okay. How are we gonna handle this? I don't know what's going on with the mic. I don't hear what you guys are talking about with the mic. If I turn that up, yeah, that sounds stereo to me, which, I mean, it's not. I can pan it left or right, but this is a mono input. So I'm just going to leave it right there for now. Yeah, I think there's pretty much nothing I can do about the deck talk. Quiet. Mic seems to have gotten better. Well, that is much better now. I changed nothing, by the way. I love it when that happens. I'm gonna run the deck talk here. I might die a little bit if it's super loud. Oh, actually, that would have worked.
The whalers on the moon. We carry a harpoon. But there ain't no whales, so we tell tall tales and sing a whaling tune. End of line.
Yeah, that kind of sounds fine. Here's what I'm gonna do. I'm just gonna filter out high end so you don't hear the hiss as much. How about that? Maybe a little bit of low end, so you just have mid from the deck talk.
The whalers on the moon. We carry a harpoon. But there ain't no whales, so we tell tall tales and sing a whaling tune. End of line.
Deck talk does seem a little quiet, but the more I turn it up, the more noise you get. So, you know, take your pick.
The whalers on the moon. We carry a harpoon. But there ain't no whales, so we tell tall tales and sing a whaling tune. End of line.
Is it like super crazy quiet? What's with the noise prior to the deck talk speaking? That is the serial transmission showing up now because the serial cable is not grounded. If I ground the serial cable, which now sounds super weird, and then run it, you won't hear it as strongly.
Your whalers on the moon.
It's still in the background, but you don't hear it as much.
But there ain't no whales, so we tell tall tales and sing a whaling tune. End of line. Whalers on the moon. We carry a harpoon. But there ain't no whales, so we tell tall tales and sing a whaling tune. End of line.
How about that? The noise isn't gone, I'm just filtering it. So like, here it is unfiltered, but then I just reduce the high end and a little bit of low end.
Whalers on the moon. We carry a harpoon. But there ain't no whales, so we tell tall tales and sing a whaling tune. End of line.
Yeah, I think we're just gonna have to go with that for now. There's clearly something horribly wrong with this setup. I don't know what it's gonna take to fix it. All right, how's my volume? Based on the mixer, it looks like it's probably okay. I'm gonna run that deck talk thing one more time, see if I can see how my volume looks compared to it.
Whalers on the moon. We carry a harpoon. But there ain't no whales, so we tell tall tales and sing a whaling tune. End of line.
It looks like it is super quiet compared to me, but I don't know. That's, I think that's as good as it's gonna get for right now. All right. Connect single-ended audio output to differential input so you don't have ground problems. I have no idea how I'm going to do something like that. I think AC part of the noise is hard to track down because it goes on and off. Yeah, I don't know. If you make the deck talk much louder, that screech is going to be annoying. Yeah, that's a problem. So, I don't know. We'll just go with it like that. If it gets really bad, I'll just disable the deck talk for now, I guess. I don't know. I thought I made it better. I don't know if maybe you guys just didn't notice before, because seriously, nothing has changed. RCA to balanced XLR input. Oh. So you're saying only connect to the unbalanced input. Ooh. Yeah, that's... I theoretically have an XLR RCA cable. Let me go see if I can find it. I may have like thrown it away because it was super bad, but I don't think I would have because the connectors are valuable. Yeah, I have no idea where it went. Somewhere around here I have it. I can't remember if I could open the ends or not, though. That was like the killer thing. I feel like one of the ends was not modifiable. So I don't know. I'll look at my options. For XLR stuff, I think I have an XLR to TRS adapter. That is mini XLR, full XLR. All right, here's an XLR to TRS. What can I do with this, though? I don't think I can do anything. That is, what is that? Female XLR to TRS. I got... Oh, hold on here. Hold on a moment. XLR to literally 8.5 mil or 5.5 millimeter TRS. XLR, TRS. That's the wrong gender. Dang it. Stupid, useless XLR garbage. I guess I just go get a regular XLR cable and patch that in, but it's going to be super ridiculously long. Oh wait, regular XLRs are extensions, not male to male. This is useless. I have no idea what this stupid cable's for. I mean, it's probably for something normal that I'm just doing weird things with, but yeah, I'm not gonna be able to do anything with that. I don't have a male to male XLR cable. All right, I have no idea. I'm just gonna have to give up. I don't have a gender converter. That's the thing. So, anyway, TRS is stereo. The XLR is also stereo. You need two mono balanced XLR inputs. Yeah, well, the deck talk is mono, so there's that. At least I'm pretty sure it's mono. Anyway, we're gonna have to just go with that for now. I don't have the cable. I want to solve this problem, not that problem. Oh, I should push this button. If it's acceptable now, then we'll continue. If it's not acceptable, I'm just going to mute the deck talk. That is the solution for now. Okay, back to this. Pin 5 looks like an output that's probably not used. So I'm going to mark that as not used. So it's either that or it's grounded. Yeah, I didn't think so, Helen Croft. So I'm just like trying to double check. Yep, looks like, excuse me, none of that is used. So 5, boom, no connect. Hold on, why didn't that paste? Nope, not VCC. Yeah, right there. Copy. Wrong chip. What do you mean wrong chip? 15. 15. That's right. Power rails. So ground seems to be going up farther, but I don't know. It could just end right there. It doesn't stick out, so we don't see that. We have zero clue how far that goes. There is no way of knowing. There are no vias that poke through that tell us like, oh, it goes up to there because this pin reaches all the way to over there. We know the power rail, the 5 volts, goes all the way through, but we have no idea on the ground. It's no problem, Lainsey, asking, because if I do miss, that's a problem. Also, Gabramax, I didn't mention it because I was trying to fix the problem. Hello, since it's your first time chatting. So, all right, 5. No connect, probably. 5 is... What? 5 is a trace escaping the chip. What do you mean? Five doesn't go anywhere. 5 is this. 7, 6, 5. 5 is locked. It's not touching that because of the dumb solder mask. And then on the top, it's not going anywhere either. Trace between the power rails. Oh. It's not necessary. It probably is 5. What's 1 on that? That would be in a logic. Oh, I don't like that. Well, here's the thing. Is it 5 or is it 6? Because 6 has a test point on it. And 5 doesn't. They're both outputs. I think 6 is probably that. Gabramax, longtime YouTube follower. Glad I catch a stream viewer so I can have something in the background while I attempt to build a Linux image for an arcade cab. Well, cool. That is something I have not done. The probably MAME type thing. Actually, I have never run MAME on Linux. Interesting. 6. Yeah, probably 6. So we'll go with that. 6 is questionably going to that, to there, to there, to there, to there. Okay, 6 goes to 1 on 10. And that's an input to an output, so that makes sense. Yoink, doink, to badoink. Okay. Seven's ground, so that goes boom, boom. This is power, so boom, boom. All right. I will actually like connect those. Copy, paste, and somewhere around here there'll be a ground. Boom. Okay. Make it so I can actually see chat. There we go. Mouse cable's getting in the way because this is like 5-foot cable for 3 feet of desk. Okay, 11 is at 8, 9, 10, 11. Okay, 11, we have no idea. It's probably no connect. Can't go through the top side, and it doesn't look like it goes through the bottom side. So that one absolutely must be a no connect. There is nothing visible at all. We can feel pretty confident about that one being a no connect. So let's grab, not that. Let's grab that, copy, paste. Boom, and boom. There we are. That chip done. Right, moves inverters the 6 higher. So these are saying, oh, yeah, no, that makes perfect sense. Let's do that. on that, I'll grab this and this. Paste. Paste. Nope. Paste. Okay. Where's that one at? Is that one... Ooh, what do I do? Let's not do that. Is that this? Yeah, that's that. Have we only connected one pin to that? Because that's 15. That's 10. Wait, where's 10? 10. 04. Okay, no, that's right. Okay. That's this. All right, that chip has nothing going on. Okay, actually not main, but it's going to be Step Mania. Okay. Pump it out, cat. Basically DDR, but 5 panels. We're converting it to something open source since the original game is in a very old... That is super cool. That is a really cool project. I like that a lot. That's awesome. I'm a big fan of stuff like that. Frets on Fire, you know, those kinds of things. So that should be pretty sweet. Is that, can you run like any song at all through that and it'll generate the gameplay elements from it? What is the floating thing? Is it just that one? Okay, that's good. Even if it can't, you probably just have to create like little MIDI sections to do it. Boom, chip done. All right. Next chip. You want it to be that one, but it's going to be this one. Well, let's do this one now. So some of these can be tied to ground in here. None of them are connected to signals. So there's that. Let's see. So ground definitely goes to at least there. We already determined that goes there because there's a test. No, there's a via. And then it... Ooh, wait. No, that means it goes on the bottom side. So that means ground... Oh, ground definitely goes up because we can see it up there. There it is. It's up. So we have this one trace, and that's it. So 14, 13, 12. Where does 12 go on this? 12 goes on an adventure. Oh, to 20. 20. It goes to 20. Boom. Which... clock input of UART? What? That would make too much sense for the chip that's near clock stuff to go to the clock input. 20 is over there. Boom. Uh-oh, getting close to the edge of the schematic. Boom. Okay, so that... I don't like... I think... does that one connect? I don't know. I don't like that. Wait. Oh, I'm on the wrong thing. Actually, hold on. I want to see this. So get rid of that. Okay, that goes to that pin. This, I can't tell anything. Still can't really tell. Let's open this in GIMP so I can actually just easily view it. Convert. Okay, none of those connect over. Oh my gosh, this image is so much better, but super low resolution. This is like twice the resolution, so it's kind of better. See, here we trace, yeah. Did Sony Philips do digital audio did do a Sony Philips digital audio because when CD was first introduced, back around 82, and again for that, but fundamentally I'm an analog guy who's digi-curious. I'm not 100% sure what you're asking, Dr. Hugh, but this is a Philips CD drive. So they both of them did do CD-ROMs very early on, and actually if you go watch a Computer Chronicles video about early CDs, that is like, I want to say it's April of 1985, which is slightly earlier than the actual release of this drive. You will see a Sony CD drive at a trade show, but I don't think it was for sale yet. This is actually one of the few times where I'm not 100% sure if the general consensus of the internet is accurate that this is the first CD drive. I really don't know. The thing is that the Philips CM-100 was not the first one to be released. It was it was a digital N5NR. I don't remember what the model number was offhand, but it's a DEC drive. That is the exact same drive. Philips just sold it to them. I found information about Philips licensing the tech out to other manufacturers instead of selling it themselves initially. And then they clearly, obviously did sell it themselves because there's one sitting right there. So it might have been that it was a non-Philips drive that was first, and then, yeah, I kind of get into this in my Byte magazine video because I talked about it a little bit at the end. Well, while I was looking at the magazines, there's a whole section on it because there was also a digital research CD drive. That was the first instance of an advertisement for a CD drive in Byte, and I think they gave delivery times that were earlier than this CD drive would have been, like it was 84 or something. But I think that they didn't actually deliver or something. I don't know. It's really weird. So, yeah. See, you essentially have folders that contain the song in OGG or MP3, a file that contains the note data, yep, and eventually video files. Oh, background videos. Interesting. I wouldn't have guessed that. In-game, you select the song, note chart difficulty. That makes sense. Kind of like Frets on Fire. So yeah, it kind of works like that. All right, cool. So it probably also has like a garbage auto generator then for songs that it doesn't have actual note lists for. See, sorry I did do because back in 82, Sony and Philips ran their cause jointly, yeah, but it was a Philips unit that we were pulling apart. All right. Yeah, they both did early CD-ROM and CD audio, for sure. I think it was obvious that the CD was destined to be used for data as well as audio because, I mean, it just makes sense. So, all right, 1 and 2 like have to be connected to something. 2 is master reset. Big stupid chip. Okay, what is MR? Memory reset, something like that. Master reset. Oh, I had it high. Active high. Okay, so if this would make sense to be tied low. So we should probably ground that. And then this just never resets. Ooh, is there a hotkey for no connect? Hold on. Q is a hotkey for no connect. Oh, sweet. I'm gonna have to remember that. By the way, tilde is the hotkey for highlighting wires. That's like my new favorite hotkey. That one's awesome. 1 goes into passives. Gross. All right. So, boom, there's 1. All right, goes into stuff. All right. Man, I hate this. Add resistor. That goes over there. Add capacitor. That goes there. Used as a clock divider. Ah, that makes perfect sense. Yeah, that makes a lot of sense. This is a ripple counter? Yeah, okay. Yep. I'm all there. Okay. Oh! Ooh! So... Oh my gosh. Click. Jumpers on a serial device, you could pick a different output to change the baud rate, theoretically. You would have to change the input as well, which would be a different thing, because I bet this somehow connects to the output. Ooh. Interesting. That, like, just made sense. Because I know what a ripple counter is. I've never used one, but I'm familiar with it. It's you kind of like I mean, it's a binary counter, so you'll get the boop, boop, boop. Yeah. Oh, interesting. Sorry for going on a tangent, but I just remembered if you need any parts for any of your Novas, like CPU interface cards, this person has a stockpile of mostly... What now? They have components that work? That are known functional? Nova CPU, is that a whole board or is that the bit slice chip? I shudder to think how much they charge for like tested known good data general parts. I'm gonna go out on a limb and guess that the SCSI 2 controller doesn't work in a Nova 4. Interesting. Huh. Well, I'll have to keep that in mind. They divide the main crystal frequency? Yeah. Full boards, and actually the hard drive interface card I got from them too wasn't crazy in price. All right. Good to know. Okay, so we got a resistor and a capacitor. It looks like a, what, 100 ohm resistor. We're going to just pretend that we didn't see that and do that later because everything's mirrored on the back right now. So I don't. That's why I haven't been trying to read any values because that's not going to be a recipe for success. Is that just grounded? Why didn't they ground it up there? You got ground right there. Why'd you have to go down? You could just... Okay. They're on the back. There's literally no reason they couldn't have just grounded that. Like, literally, just flip it around. Have the capacitor right here instead, and then, boom, there's ground. What? Why? Why did you go down to that ground? We're not fixing their stupid design. It is 100 ohm? Alright, that's what I thought. In the schematic, I move a few inverters crystal to counter it together as a group. You moved them? I don't know how well this will merge, like, changes if you're going to try and push those changes to the repo. Theoretically, a schematic file in KiCad is just a text file. So it might actually be able to merge changes, maybe, but I don't know. Oh, you would move them. Okay, okay. And schematic, 101, same backwards forwards, upside down. Yeah, I know. That's why I said, like, it is a 100 ohm resistor, but we're going to pretend that we didn't see that because there's other things over here, like this 201 looking thing. So technically it's like that, but then it's mirrored. So, you know, it'd actually be 102. So that's why I was saying, like, we're pretending we're not seeing it because it's mirrored, and I'm doing all of those later. So. Alright, okay. In the schematic, I would move a few inverters, crystals, and counter together as a group. Yes. When we get to that, like, there's going to be a whole bunch of that up there, for sure. I don't know. There's optimizing the schematic, and then there's actually getting it done. Right now, I'm just trying to actually get it done. Anyway, let's ground the capacitor. This. Boom. Boom. Oh, wire. Why? There's a no connect in there. Why would it even let you put a no connect on a trace? When you clicked previously, it used to ask you, like, are you trying to select this or that? Now it just doesn't. Anyway, there. Okay, resistor goes to pin 8. Yeah, pin 8 on 10. That's an output. Okay, that makes sense. Boom. So that's that. All right. Oh, I didn't actually connect it. That would be smart. Let's do that. Okay. Rotate resistor. That would make sense too. For right now, I'm going to leave it. I don't think it's going to matter too much. And it matches the physical layout of the chip, so it's easier to keep straight. I don't like that none of the SMDs have ref deses, but that's just how this era worked. They just sprinkled this kind of stuff all over on the back. Like, look at the bottom of a Voodoo 2 sometime. It's a nightmare. Okay, I think that's it. There's a capacitor down there. Hello, Cookie Jar 6502. I think we can... I'm going to ignore that one for right now. There's a bunch of decoupling caps all around that I haven't done, like that one as well. So, yeah, chip done. Boom. That was like the easiest chip in the whole thing. Okay, so we have the crystal land, and then we have big caps, just another VCC filter. Yeah, it's just that it's physically placed next to your, I assume, for it, because it probably has the most grunt out of everything here. I mean, it has to. It's not a 74 series chip. So all of that's going to be connected, and all of this is going to be connected. So we only have 2 logical blocks left. We have the crystal input, the timing generator for the whole thing, and then we have the buffered output. Two inverter in series crystal, parallel the first inverter. Yeah, Cookie Jar, this is, as far as I'm aware, literally the first CD-ROM controller ever. And it goes with my literally the first ever CD-ROM drive that I have sitting over there. The Philips CM-100 is the drive. This is a Philips CM-153 controller, as it says right there. This is also going to be fun. I'm going to try and recreate this silk screen, but these are really unusual characters. So we'll see how close we can get, but I'm not optimistic. All right, let's do this. Wonder what the use case for these would have been early on. They shipped with a copy of Groyler's Encyclopedia. This one was used at a school, so they might have literally just put the CD that it came with in the drive and connected it to their like network, and then told students like, you want to look something up? There you go. But they would have been used in medical industry as well. Oh, we didn't do the resistor. Oh no, we did. I just didn't mark it. Okay. They might have been used in the medical industry as well for reference material. You could have like a lot of documents on weird diseases or like anatomy stuff. So, yeah. All right. Add X. T. A. So did they call it crystal? Oh, they do call it crystal. That's weird. All right. I mean, it's not weird, but it's weird. Okay, it goes into this. I know crystal's not going to be that bad, but yeah. Ooh, crystal circuit. Hello. I like that. Ooh, that's a thing. They don't have caps. There's stuff. All right. Well, we'll take a look at that as we get to it. I think I want to rotate this though. All right. This one's better. All right, let's look at that. Yeah, that does look more like it. One resistor connecting some stuff. Yeah, all right. Let's work on this. So, where does this trace go? Can I get this out of the way so it's like less of a pain? I think I can. Let's do this. Boom. Delete. This will make a nice big spot up here for a bunch of crystal-y nonsense. Okay. Add capacitor. get some grounds up in here. Okay, we 100% we make the same thing. All right. Remember one of those early multimedia encyclopedia CD-ROMs had a video of Saturn V launch, JFK voiceover. I must have watched it dozens of times. That's cool. I really want to find the 1985 Growler's Encyclopedia CD, but like, you know, I want to find a Yeds 1 as well. For the first of anything is never that easy to find. All right, nice. Discord just gave me notification on my phone for the stream. Really? Just now? Wow. That sucks. I even tried. I did the full, like, published an announcement thing in the Going Live channel. Man, that's annoying. So, two things, actually. One, I've mentioned this before, but I'll mention it again. If you don't get notifications from Twitch directly when the streams start, try going into your notification settings page and disabling smart notifications, because that is meant to not notify you in some instances where it thinks it can already notify you in a different way, and it has this like list of precedents. So you might want to try disabling that if you don't get notifications. Secondly, I think somebody bought the computer case that will hold the floppy drives. It has not shown up yet at the PO box. If you did do that, if you have tracking information, it would be really helpful if you could give me that. If not, I'm gonna keep checking, but it's been definitely over a week, maybe two, and I want to make sure. So yeah, all right, that's it. I've been meaning to mention the computer case thing for a while. So, alrighty, let's continue. There's a resistor that connects. Is that connecting everything? I think it's connecting. Let's get all the drawing layer out of here. Backside. Resistor jumps over some stuff, but definitely connects the two sides of the crystal. So let's do this and this. That didn't even come close. Really, Trace? Come on. Alright, add R, not T, R. Move photo on the right so we can see the chip. What chip? That chip? There's that. I think that's what you want. There you go. And that would be good too. Oh yeah, I guess I am going to be connecting it to the chip now soon. Okay, but I want to work on some other stuff. Like, are those are just test points? Wow, why do they have test points just coming off of the crystal? Do they just want to make sure their crystal doesn't suck? Is that all? It's like not a whole lot of other reason to have those. But alright, they're there. Also, the ref des for this, XTL, it won't let me have this. Oh, it will! Ah, cool. Alright. 1011 inverter is parallel to the crystal. Alright. Well, let me work on this. Here, I'll figure it out. So, okay, this is marked. That's on the... Wait, is that... What's wrong? Why is that not full opacity? Force is 50%. Is that... No. I'm not on that layer. Oh, it's the airbrush tool. Oh, that's super weird. Okay. Pen. Soul. Boom. 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 Okay. Boom. 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 Alrighty. Man, I'm just thinking of doing something stupid, like hooking up this drive to a much newer computer for, I don't know, the world's slowest installation of Half-Life. This will probably not be able to install Half-Life. This CD drive does not support ISO 9660. It is High Sierra, which means that it will be 8.3 file names only. So, yeah. Okay, so this is pin 8, 9, 10, 11. Okay, so I'm just gonna yoink this, because it sounds like probably isn't gonna be staying down there. Oh, why is the ref des way up there? Come on. So that one goes to 11. I'm gonna go ahead and drag this down and that. Get myself some space. So the clocky clockness can do its thing up there. All right. So right side of crystal goes to 11. I will double check that. 8, 9, 10, 11. Okay, and it looks like the other side's gonna go to that, so we'll just boop. And now I feel really silly. I didn't make all this just slightly bigger, so I'm gonna do one of these. Boom. Boom. All right. No, don't rotate. Don't like that. Boom. There you go. I'll move that right there. Okay. Next up, well, actually, I can do that to that to that to that to that to that. All's good again. All right, let's see. Would it be tricky to burn CDs that will work in this drive? It should be pretty easy, actually, as long as you respect the 8.3 naming convention. I think it'll work. The main thing is that a lot of newer CDs use the Microsoft Joylet extension, which is what allows you to have longer file names. I think as long as you don't have any names that are longer than that, it won't matter that the data will be saved in a way the drive can read, because I've heard that these drives can read ISO 9660 file systems because High Sierra is what was used to create 9660. So I think it'll work as long as you stay within the bounds. So that's just my guess. Obviously, I don't know because I've never been able to turn on my drive. I mean, I have, it just, you know, I can only watch it spin disks. It can't actually, like, do anything. All right. Pin 9 to 10, probably. Yeah, let me get back to this. Okay. 9, 8, 9. I don't have a connection to 9. Does it go under? That's scary. Just use drive rewinder speedies. Yeah, it does have a dedicated run button, whatever that does. Okay, so we got some other stuff. So we got, oh, there's a lot of vias in there. Ugh. 9 is input needs connection. It does indeed. 8, 9. Crystal's going, oh, I'm not saying it's done. I'm not saying it's done. I'm saying, like, how do we connect that? This is why I was putting off this chip. Oh, we have some speculative connections here. Are we really saying that that trace goes to that? Hold on. Really? hold on. I may have made a mistake here. So we have a via that's next to that. It would make more sense if this went like into there. What does that go to? That goes to 125 pin something. I don't know, whatever. It's 11. Okay. Pin 14, 13, 12. Pin 12 on 11. Here. Okay, I think I marked that one as not sure. I think it's gonna suck. Do you have a spec sheet for that chip? What's the empty pin? I do have all the data sheets. Blackbird, you can go to here and see the GitHub repository where all this is being hosted, and then I have links to data sheets for every single chip. But that's an input to this or that, which I've already done. Why did that not work? I gotta go look at that. You didn't put an emote in there. Do you have like a weird character? Your ellipses is one character. That's what did it. The 3 periods after the word life. That's one character. You copy pasted that, I assume. That one character made it not work. I haven't. Yeah, it says ASCII can't encode character in position. It's not within. Yeah, so I think that's what did it. It's not. I'm not gonna really say that's your fault. Like, it's a weird issue to have. But yeah, that was a thing that happened there. There's another one it doesn't like. $137. What else could it be? Do you have like a weird comma or something? Oh, I bet you got stupid apostrophes. Yeah, you have dumb apostrophes. Man, you got all the issues in there. So you have bad apostrophes. You've got an ellipses. Yeah, I can tell what you typed because they're normal apostrophes. But yeah, when you copy pasted all the stuff, it had all sorts of dumb characters in it from an overly pompous website. I'll leave the commas and hope that they're correct. half expecting the question mark to be weird.
How have things been going? How's
Why didn't it
Gulliver?
work? That time it
Also,
didn't
did
work
you
because it
ever
just
hear
didn't
the
work.
tragedy of Dark Plank as the
What?
wise? I do not. It's not a story the G would tell you. It's a Sith legend. Dark Plancus was a Dark Lord of the Sith, so powerful and so wise he could use the Force to influence the midichlorians to create life. He had such a knowledge of the dark side that
Oh,
he
wait.
could even keep the
It
ones
is
he
working.
cared about from dying.
Oh.
The dark side.
Text overrun error. CHER 100 end of line.
How have things been going? How's Gulliver?
Oh, that's my
Also, did
fault.
you
I
ever
sent the
hear
same thing
tragedy
twice.
of Dark Plancus the wise? I do not. It's not a story the G would
There
tell
we
you.
go.
It's a Sith legend. Dark Plancus was a Dark Lord of the
Okay,
Sith, so
all fixed.
powerful and so wise he could use the Force to influence
Back to your
the
regularly
midichlorians to
scheduled
create
nightmare.
life. He had such a knowledge of the dark side that he could even keep the ones he cared about
Wah!
from dying. Dark side.
Text overrun error. CHER 100 end of line.
I don't know what its issue is at the end. First off, Jocular Space 671. Hello, since your first time chatting. I am not going to be doing a Windows Server 2003 20th anniversary. That would be almost impossible to get a brand new server. Barely see servers like that come up for sale because those just get churned through so much. Yeah, that's going to be a tough one. I could attempt to build a computer, but that would be, at that point, they were using Blade servers. So, yeah. So, all right. Let's see, Deck Talk hating on the meme. I don't know the meme, so, yeah. So, I'd love to get into some troubleshooting. I have a home receiver quit on me, but an oscilloscope seems like a huge barrier to entering the hobby. Look on Craigslist. You can get analog oscilloscopes for fairly cheap, so you could do that. I don't know that that's really going to be the thing that you need. Probably just recap it. That would probably be what I'd go with. Maybe just Google the model number plus capacitors. You might find out that some of them just go bad. See, 9 is going to 10. Look at scan 85. Let's look at that. Boom. Is that one of those ones where it's on the top side? I'm really starting to hate those things. What is this here? Yep. Man, that's so frustrating. I'm now learning anytime I go to make a PCB where there's two pins right next to each other that are traced, I need like a big old loop that pokes out, and then maybe have them make the solder mask bright orange right there or something, just so it's like really obvious, because that is so sneaky. But very good catch. Thank you, Helen Croft. Xserve anniversary video, that's not happening. Again, anniversary videos mostly require me to have something new. I didn't do that for the 25th of Windows 95, but that was kind of just stars aligning. So, some $60 Chinese oscilloscope kit Adrian has looked at, used for trying some repair old hardware successfully. Yeah, definitely not anything Temple OS. That's not happening. Ah! All right. I assume that's a joke that I don't know. Okay, so that's 9 to 10. That makes sense. All right, we'll grab that and just boop. Man, there's so much noise coming out of the Deck Talk. Holy moly. It sounds like one of those sleeping by the ocean audio CDs over there right now, because the speakers are just... I rotated the resistor. I really appreciate it, Telegraphed, all the help. Making a massive difference. And even just the extra set of eyes helping to look at stuff. Nice timing circuit, just like I expected. It is definitely looking like what you were predicting. Is there anything we're missing? More passives or stuff? I don't know. There's one right there for the chip that's probably just stabilizing it, but again, I'm going to be going through all of those after. See, it's most likely SMP causing wild interface. Might be. What was it, 96? Almost certainly would have shipped with a linear one at that time. It's also meant to be battery operated, so it might have like really terrible power filtering to begin with because the battery is just smooth. So, yeah. All right, so that's ground. That's power, and then there's that capacitor there we're ignoring. Connected, 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 connected. They're all chip done. Chip done. Crystal done. Boom. We have to do the input buffer, and that's it. Yeah, it's internally switch mode, but it might have only shipped with a linear external. I did find a picture of the external power supply, or someone did here. I did find one after the fact as well. And it looked like a big chunky linear one from the air, not like like it'd be potted or whatever. So that's a big chip to cross off right there. Boom. Can you just put 2 or 3 4700 caps in series and see if that helps against the power supply? Not as much as you might think. It's not just that you need a lot of power, you also need quick power at the right frequencies. So if you have, like, let's say there's a part on there that's on maybe the internal switch mode power supply that's running at like 10 kilohertz, all right? That means that at a 10 kilohertz rate, it's drawing in power. And if the ESR on your caps that you put as like the big power filter is high enough, that 10 kilohertz signal may not actually be able to draw power out of those capacitors quick enough. So you might want, say, 3 4700 UF caps in there, and then maybe 2 100 nanofarad ceramics, because those have extremely low ESR. So it's a little more complicated than just putting a bunch of cap power in there, because not all capacitors perform the same. That's also one of the differences of why you would have different applications with some electrolytics, some tantalum, some polymers, some ceramics. So each one responds differently in circuit when you use it. So like you did Windows XP 98 builds. I was around when Windows XP was still going and missed the games. Have you tried an original Xbox with Windows XP together? I don't know what you do with XP on an Xbox, but I have played a lot of Xbox, original Xbox. So, switch mode power brick doesn't have ground pin, so it uses outgoing ground to get rid of noise. Switch mode, so outgoing ground to get rid of the noise. Okay, so you're saying the original power supply sucks. I wonder if it could make sense to get a linear power supply at a lower voltage and just feed it through the battery port. See, yep, that's why you don't just replace ultra low ESR caps with just some random lower ESR caps. Yeah, for sure. Okay, I'm half tempted to put a green box over the crystal, but I think we're good there. There's gonna be so many test points to sprinkle around here. Wow. Can you believe how close to done we are? Like, what? Look at this. We are so close to done. We have a couple of like scary things that we don't have like good leads on, but you know, let's just not worry about that. Like, I really didn't answer as many questions underneath the UART as I'd hoped. Well, I mean, actually, how many traces we have here? 1? Yeah, 1. 2 if you include that. See, linear bricks don't have mains. Mains filter inside the switch mode power supply bricks uses outgoing ground for filter noise. Okay, linear bricks don't have mains. All right. Alrighty. What do we have going on here? So that via exists for a reason that we don't know. Same with that one. That one probably, I'm guessing, goes to 1, but I don't know. Why did I say That makes sense. Let's look at that. I want to look at the serial chip. Let's work on the serial chip. Let's finish that up. So this is pin 21, 20, 19. Pin 19 is TX. Okay. And I marked TX as going out to that thing, which diff stuff's probably going to go to the connector, and then 2. Now, if we go up to here and look at the LMSI pinout, we will see pin 2 is command, which would make sense for TX to be called command. So that might be it. And I think on here, I'm not 100% sure, because I mean, I really just have no way of doing it. I think all these are bust. Oh, can we see on this, or is there plastic all over it? I closed the one I wanted. No, I didn't. Here it is. Yeah, it's too much plastic. I'm kind of guessing all of these are bust. Can we do drawings here? Hold on. I'm guessing all of these are bust ground. Check the 16-bit card. You know what? I can for that. You're right. Let me grab the multimeter. I was just thinking about it for the buffer nonsense that we're going to have to deal with. But yeah, this makes total sense too. Actually, I probably just look at the back. Not really. Okay, so pin 1. Yeah, so I don't have the CM-153, which is the card that I'm trying to reverse engineer, but what I do have is a later model card that I bought instead, trying to make it work, and then it didn't. So, yeah, that's a thing. Why is it there? Okay. Continuity test. Good. Okay. So, are these all ground on the backside? So, bottom or top, bottom, that's not connected. That is. That's not. That's not. That's not. That's not. That's not. Oh, that's concerning. Here. No, 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 no. Uh-oh. So bottom and 2 are ground on that. They are not. Here, there's a diode drop across that. That's... Huh. Also... Oh, that has the same key. Ugh, gross. Alright. There's something weird going on. Well, on this card, on the right side, the top one and the second one are connected, but then none of the others are. Even though on this schematic, the bottom one and the second one are connected. That is not true on this card. There's a diode drop. And I don't know how well this will come across on there, but there's a key on the connector. Is this even going to show up remotely? And the key does exist, or is missing, I should say, right there. We can see the key is there. So we know that it is technically the same connector, and I have the same orientation. Not even the last one? No, that's what I'm saying. If I measure the last pin there and the second one there, they do not have a solid ground connection. There's a diode drop. It's 0.5 volts across. Same up there. So it's almost like that one has a different use now. Is it this? I wonder if that could be part of the different protocol between the newer version and the later version. Ooh, you know, actually, that doesn't support audio. This does. So they would have had to repurpose some of the inputs or some of the pins for audio, and they would have obviously had to take away some grounds for audio. Oh, man. So yeah, top two are ground. None of the other ones are. No audio, still separate cable. Oh. Okay, I see it now. Yeah, that is all over there only. Alright. So that still doesn't explain it then. So the command pins are all diff pairs, but I don't think they're diff pairs on this connector. I think they're just digital. So they're only diff pairs on this. Yeah, that's what I was thinking, Alan that is probably ground. That's definitely ground. So we can visually confirm ground there. That's not ground on here either. There's like way more grounds on this than that. Or that than this. Internal single-ended. Yeah, that's what I thought. So yeah, pin 8 here should be ground. Not ground over there. Or it's not ground on this. Pin 9 should be ground. It's not ground. Are those two connected to each other? They are not. Maybe they just didn't bother connecting those to anything? Nope, they go somewhere. They go under the buffer chip. So they're some kind of signal. Signal ground versus case ground. Could be through a diode. So let me look through a diode, or look for a diode on here. Because I don't think I'd run all the grounds through one of the buffers. I don't see a single diode on this whole card. Additionally, they're not connected to each other there. So, like, even if they were signal ground, every single one of them's different. That would just mean it's differential then, because none of those are connected to each other. The only two that seem to be connected to are These two. Those are the only ones that I can confirm are connected on this card. And obviously here, that is connected. So, and then it may as well connect through to that pin as well, because that's also ground. Matter of fact, that might be how that's getting ground over there, because I don't think... Oh, we can't see squat there. Oh, it's on the back. I accidentally closed the back one. One moment. That is 85. So let's open 84. Open with GIMP. So like one on the top side. Yeah, it couldn't get ground any other way than through this. Those aren't grounded. So yeah, I don't think the shroud has solder lugs. No, they don't poke through. So yeah, that's got to be how it gets ground. So that's kind of hilarious. So it gets ground on the top side through that, because there's a trace that goes into it there, which runs on the bus for ground. So that's hilarious. It's thin and then it's thick. But then it connects there. And then probably there. I think this might not be useful. Does this new one have like just a totally different pinout? Is that what it is? I wonder if there's grounds anywhere else on here. Actually, that does connect to normal ground, right? Yeah, that does. Yeah, there's no other grounds on that connector on this card. Not even the key. There appears to be 6 signal lines coming off of this connector. We have 1, 2, 3, 4, 5, 6 coming off of there. Well, that's ground. It's a multi-layer card. It has an internal ground plane, at least. Oh, that's super gross. Why? There's so much wasted space. It did not need to be. Yeah, I think I'm going to have to just disregard this as not applicable, because it doesn't seem to line up. Yeah, Raymond, for the card that I'm doing, yeah, that would be impossible then. I would have to just give up. What do you think the chances are they added more data bits for this? Because it's a later revision in 16-bit card. Because it's basically the same card, but now it's 16 bits instead. Maybe that's the difference in why it's not compatible. Maybe it only speaks 16-bit. Well, not necessarily 16-bit, but maybe more bits. I don't know, because... yeah, I can't figure out any other options from here. I don't think there's traces running in the ground plane. I will say that. Because I can shine light through it, and I don't see any regions where there's like a big, wide, open area. So I think they were actually good about not doing that. Yeah, this does not seem to be that useful for determining the internal connector pinout. Thankfully, I don't need the internal connector, and I won't be able to test it. It might be possible to take apart the drive in C. The person who sent me the schematics, actually, well, not schematics, the images, they disassembled theirs, I think. See if the internal drive in there has that connector. If it has like a signal diff interpreter inside. Yeah, there's my post where they replied. So yeah, like here's their exploded view. They may not have. Hold on. So that could be external connector is where it's on this bottom board. Big old power transistors, because I guess this thing uses a lot of power for some reason. I don't think that's data for the drive. Could be a data for the drive over there somewhere. A lot of ribbon cables in there, though. You have a PAS16 with an unpopulated LMSI interface? Ooh. So you might be able to see which ones are grounded then with each other. All right. I'm curious if you can confirm that on that only these two are ground, because that should probably be the same as the CM-260 here, from what I've been told. But pretty visually obviously on this card, we have, I mean, we definitely have a connection here. That we can confirm. And then we have a connection to ground here. We cannot confirm on this whether or not those are connected. We can assume, because this is labeled ground, and it should be ground, and that is ground. But we can't be 100% sure. So we can mark this yellow. Shelby, did you ever say if you had any LMSI sound cards? I have no sound cards that have it. This is literally the only LMSI card I have. I bought this specifically because it was an LMSI card so I could try the CM100 with it, and it did not work. To the best of my knowledge, all of the sound cards use basically the same chipset as that. So there's not going to be any difference between this and a sound card. This is dated 93. Pretty much all sound cards would have come out after this. So, yeah. Trying to get a confirmation on that. The date codes are the RAM buffer or whatever things those are. I guess those parts could be older. It's hard to tell. It might... Well, that doesn't make sense. I was going to say that could be the date code, but no. Not unless there's a 65th week that I'm not familiar with. Bummer. Standard wasn't more... it wasn't more standard. Yeah. I just need to buy a CM-150. It's the same exact CD drive, but scuzzy. But then it's not the first. So, you know, gotta be able to say first so people click on the video. Oh, water's good. So then we have no idea what those pins are. I don't see any sneaky interpin traces on the UART, so we can eliminate that. Real shame that SCSI wasn't more common, solved a lot of problems we had with IDE. Yeah, no, in general, SCSI was pretty nice. All right, so there's this pin, pin 4, which would be data clock. Oh, great, clock stuff. Sending pics on Discord? All right. I might be a little early. Perfect, okay. So pin 1, okay. And yours has internal ground plane as well. Ooh, that's interesting. Yours is numbered differently, I think. Could that be it? Yours is kind of pinned out like I expect mine to be pinned out. So on yours, I would expect pins 2 and 3 to be ground. And it looks like the rest of them have reliefs cut in the internal ground plane. Except maybe that one. That one might not. Oh, actually, can really see in the reflection under it there. Let's see, where's that at? There it is. Ooh, that's a high resolution picture. Yeah, if we look right here, we can I can actually see. So there are X traces in there for thermal relief. So those are grounded. We can see that they're cross done in there. This feels like I'm doing astronomy using gravitational lensing to get a magnified view of an image while indirectly looking at it. But we can see, yeah, those 2 pins are grounded and none of the rest are. Yeah, 2 and 4 are grounded. Those are not. So it's an 8-pin interface, basically. That's amazing. So maybe because they're not being used, they just went through them down here. Because, I mean, there's a 100% chance that that pin is connected to up there. So those 2 almost certainly go like that. I think we're going to go with that. So that matches this, other than the fact that my pin 16 has something connected to it. Mine has more connected than yours does. Extra pick? All right. Takes a little while to come through. Probably taking time to upload. That was a really high resolution picture. So routing through unused pins is a thing. It's done sometimes, usually only higher pin count chips, but it's still possible. Yeah. Oh, perfect. Yes, that tells the tale for sure. Okay. So definitely only those are grounded. Yeah. All right. On this, though, I think those bottom 2 are. So almost certain is a good way to make a burn spot on first power up. 10-10. So what I'm going to do is pretty much anywhere there are yellow traces here, I'm going to have the person who has this card and released that video, they've offered to check stuff for me. Like if I had any questions, they've offered to check some things. So what I'll do is this is their card right here. This is actually not the one that I am using this from. They have 2 of them. And I'm going to have them do any checks. So just continuity tests between here and here. So that might actually save me some problems later on. And then we will, we're going to like super ultra uber duper protect that CD drive. We're going to run it on a test bench with no card first and see if it just goes up in smoke. And then we will connect the drive with it. Since it's diff pairs through the buffer chips, I think we're probably going to be safe because we're not going to get any errant voltages through the external connector. The internal connector could not work, and we'll never know because I'm not even sure there were any internal drives that could plug into that and work in this era with the weirder, different protocol. So, yeah, and I'm guessing a different protocol is actually just a different clock speed, but, you know, Much better last picture? All right. Oh, yeah, that answers all the questions. Yep. So it's really weird how yours are... Okay. So, 1, 2... That's... Okay. It's weird. I only say it's weird because I think... So, I picked a clockwise or counterclockwise numbering for this. I picked a counterclockwise numbering for the part I was using, but obviously they're using staggered. But the counterclockwise numbering matches the external connector, I think. So, yeah. So as I want to say, I'm going to head off now. All right. See you later, Jout. Hopefully there's not much more to go. Yeah, so we have to do the serial and then the buffers, but once we kind of have the serial done, I think the buffers are just going to like fall into place, so I don't think it's going to be too much work. There's a bunch of passives that's got to be sprinkled around, but that's it. I don't think we're going to actually get started on the PCB, unfortunately, but tomorrow we're definitely going to get a huge chunk of PCB done. So that'll be fun. All right, let's see. I just want to check one. Oh, I don't know where that went. Never mind. So yeah, that answers that, but yeah, I'm gonna go with this because that matches the connector. So even though that's probably correct for how they looked at it themselves, this is better. And I'm not putting pin numbers down, so it doesn't matter. This card only has pin 1 done, so we're just gonna do that. Also, buffers have diff in and out like DB15, so if you have one of them, the other half of the pair should follow. Yes, yeah. So that'll be super. That's part of why I was saying it should just fall in place. So, speaking of that, we have clock input is pin 1, I'm pretty sure, based on this. No, response. What is response? Hold on. Response plus. I don't know what that will be. Well, I can follow this down to here. So it goes to that pin there. Let's do this way. This pin goes there, to there, to there, to there, to there, to there, to there, which goes somewhere. I really hate a lot that there's a via right there and right there. This has to go... It must go to this. That's the only thing that would make sense at all, because there's a trace right here on the bottom side. Where exactly does that go? Yeah. So yeah, so there'd be a trace. There's 2 traces running parallel. This has to go like that, and then it will go there, there, and there. But I don't know where it gets data. So I don't know what response is, but we don't know where it actually gets data in, because down there it just goes to the buffer. So this via is how that actually gets a signal. So this goes somewhere off into here. Oh no. That might be the most complicated one that we have to do. Oh, this gets even worse. I've made a mistake somewhere. I have to have. Yeah. That sucks. Something is wrong somewhere. because these yellow traces are other ones that I have that I assume go like that, but that would completely box in that via, so it couldn't go anywhere. Unless whatever that one is touches that to give it data. What is that? 14, 13, 12, and I do see your message there, Helicroft. 12. 12 on the UART goes to that. Would that make sense as a response? Whatever CD is? I don't know what that is. We can do the buffer next, I guess, and just bury our head in the sand on this thing. $12 makes sense. Alright. I like that. They don't just have a pin list. Command data. Okay. That also sounds like it would make sense for both the command and the data pins. So. Okay, read write logic control, CD, okay. So that would be response. So where does the other end go? It goes to address 0. Would that make sense? So it goes to ISA address 0. Okay, so it works like an address pin, and I'm asking if it goes to an address pin. So that totally makes sense then? That solves 100% makes sense. Okay. Then I will route this through that as like a way of showing that that's connected, and we will just connect. I kind of don't want to go through there. This to 1. All right. So we're going with that, I guess. 3. 1, 2, no, 4. All right. 4. I'm kind of feeling like just tried to figure this out. We got one more. Is it? That's ground, probably, whatever that is. Pin 4. Pin 4. Oh, pin 4 is just ground. Okay, well that makes sense. Why would we connect it to ground? So that's that one's ground. Okay. We 100% know that trace exists, so we don't have to like even yellow that one. That can be green. So let's do that. So this goes in. Yep. And then we have no real strong indication of where it goes, because there's nothing else until that. Where does that go? Could it be that simple? Are there any other vias we have not attached to? That one, I think, and maybe that one. That goes to pin 13, 12, 11, 10, 9. TXC. So TXC to pin, what did I just do? No, pin 4. What is pin 4? 4 is data clock. I forget what TXC is. Transmit control, TXC. Is that a clock? Sounds clocky. Ah, here's pin descriptions. Okay. TXC transmitter clock. Ah! Hello. So, data clock 4 connected to this makes sense. So it could just go boom. Well, I'm speculating on that. So it could go like that. That would have to go, that makes sense because something has to go down to the buffers. So let's say it's this and then that. Why does it go over here though? I don't like that part. On the backside view, we have, which one is it? It is 2 holes after everything. So it does not connect there. It does go there. That would, is that the 5-volt rail? Is that a thing that exists? The 5-volt rail must end right there because there's stuff over there. That doesn't make sense. But why is that there? I need to, real quick here, before I get too lost in that. This 12 goes to pins 9, 10, 11 on the output buffer 21. Or not. What? 9, 10, 11 on the 21. That doesn't make sense. Why would one of the diff pairs be connected? That's a diff pin. That should just go to resistors and outputs, I assume. Oh man, it's gonna be such a nightmare to figure that thing's pin out. Oh my gosh. Oh, this is gonna suck. That's why I'm putting off the buffer, because this whole thing is gonna be the worst. I will probably end up labeling the pins, for one, with what I have here. Because that will help a lot, because I have that kind of figured out, and then we know where they're going on the schematic to different things that are clock or data or what all that nonsense is. So that'll help. Yeah, that is pin 11. Goes up. Why? Where's 10 connected? 10 goes down, then back to ground, so it's pulled down. Does it connect on multiple things? Why? Wow, these test points are awful. I think it goes under multiple ones and then just disappears there, I guess. Gross. That goes under... Is that, I think that's ground, actually. Nope, that's 5 volts. Okay. So that's probably tied high then. That's where it goes. I was looking at the wrong part on the schematic. Wow. I might have been at this for a while. Okay. Oh, no, that was always correct. That's all of the inputs, signal-wise. There. So that's those. Done. Okay. Alright. There was no problem to solve. It was... Well, actually, we still have the mystery via up there. Why? Why does that one exist? Is it vestigial? Is there a test point I'm not seeing? Does it not connect over there like I think it does? Because that's an option. It could be that there is no trace over there. These connect down. We don't currently have any reason to connect that, other than I think actually we needed a data pin. Oh yeah, that's why. No, we have to have that connected. That went to what? 13, 12, 10, 11, 9. 9, no. Why is that connected to 12? Hold on, what am I looking at here? This is 13, 12, 11, 10, 9. Okay, I'm bad at counting, I get. Wait, yeah, what? No. looking at the wrong thing. That... What did I do? Supposed to be looking at pin 1. Pin 1 to 12. Okay, that tracks. All right, hold on. That's good. Okay, we're looking at pin 4. I've not done anything for pin 4. Wow, okay. That's why. Pin 4 to 9 was transmit clock. Okay, that felt right. Okay, so we're going to go here, boom, to there. Okay, and then this, let's say we go down to there. Let's actually have a thing there. Okay, and then it goes boom, 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 boom. I don't know why it's going to that one, but that's 9, 10, 11, 12. 12 is that? That's different. Does it go somewhere else too? Because I'm a little weirded out by that. Ah! This is the one I'm thinking goes somewhere else too. Oh. Uh-oh. Where? What is pin 12? 31. Let's look that up. 31. Why didn't I put these in order? Because I was doing it quick. Oh, I did put them in order. I'm just working too fast. Okay. Pin 12 there. Z data line. What? This is a 21, not a 31. '21 is a part number. This is a 32. Been staring at these things for way too long. That's a UART 32. This. Okay. Pin 12. 12 is G. Active, low, select. Okay. So would that only... Okay, this is transmit clock that we're connecting it to. So enables the output, yeah. So it would be when this thing's transmitting data, because we're on pin 4, data clock. When it's reading data back, it's saying get the data, get the data, get the data. That way it's not getting the floating state between stuff. Okay, that makes sense. Does it? But okay, that's to send out to the CD drive over diff pairs. Got it. That makes sense. Okay. What doesn't make sense is this via still. I really hate that thing. Why is that there? Is there anything else that needs that signal? Because I can't think of anything. Doesn't need to go over there. That's done now. Theoretically, we don't have ground connected, so it'd be... Over here would be this, to that, to this, to that, to that. to ground, theoretically. There's something going to every single pin of the UART except that. What is that? Fourth down, 27, 26, 25. What's 25? 25 is RXC. Well, it wouldn't make sense for it to be connected to both. Unless it does. I don't know. Could it be bidirectional data clock? Could it be connected to both? It could go, yeah, it'd be clear to go straight across from here to there. There's no reason it couldn't. But it would be just straight up. Well, we have everything else straight up directly connected. Both timing inputs. Would they be tied to each other? Could they be the same signal? Do they have an application diagram? It looks like they... Oh, look at that. Look at that. That makes sense. We've got it. So this goes there, and then that goes over to that one, which we can mark as actually for real probably connected. Boom, boom. That's the UART done. That is every pin on the UART connected to something. That doesn't make sense.
Lars says CHER 100.
End of line.
Lars, thank you for the 100 bits. Definitely don't need cardiac exercise after the streams anymore. Okay, here's my problem. We don't have any data outputs. I would think those would be connected to the UART at some point. Maybe they only connect off into the chips that feed the UART. Does the UART take serial data only from other things? And that's why we don't get it. So this other stuff, or the 595. Oh yeah, the 595s. That's kind of like a big deal, isn't it? Yeah, those are. Oh, you know what? Yeah, that's where it gets data. Okay, that makes sense. But it would output serial. But okay, it has to get data back. No, out. Yeah, so that's the only output that's connected, but we have like 3 other. Maybe we don't use 3 other. No, we have to have. Is it possible we only use 1? Okay, what is this? This is the 31. Okay. That's the 31. All right. It has two. Is this thing just almost completely unused? Is that what it is? We have our one trace that goes down to this, and it's this pin 9 goes to TX. Is that it? I mean, if that one's for transmit, it might only need to transmit one thing, and that would be 2 commands to get data back. So maybe that is it. Maybe there's only one pin or one signal used on this. And then the rest of these are just wasted. You know what? I think that's it. I think we're about to figure this out. Okay, let's do this one. So I think this is going to be super easy. All right. Pin 12. Probably just tied to ground. 9, 10, 11, 12, tied to ground. What do you know? Alrighty, so let's just grab that, and I bet we can just put that on ground and then not worry about it, because I don't think there's any other traces going to those. So, boop. And let's go ahead and grab this thing and push it out of the way. Push this out of the way. Yeah, because I'm pretty sure I'm going to be dropping a lot of Qs in here. No connects. Okay, 10 and 11. Hey, what do you know? Those go places. So those are doing something that obviously is resistory. But we got pin 7 here. What's pin 7 doing? Pin 7 is an input, and it is tied high. Oh, let me draw a line here. Boom. Okay, pin 7 input goes to 5 volts for some reason. I don't know why. Boom. What about 15? 15 here? I don't know. Wait, is that? Hold on, that's 16. Where's the pin 16? I don't know, but pin 1 is tied to 5 volts, so that's a thing. Boop. All right. 15 could just go straight there. So I think from context, we could guess that's connected. Like that. Makes sense, I'd say. I don't know why this one's connected on the back. Why didn't they just do it on the top? They got it right there. But they did it on the back, which tells us probably. So I'm going to go ahead and grab this thing and move it over here, and then run a thingamajig there, and then I'm gonna grab one of these. I'm gonna put it right there, and one, that was an input. These are all connected to power. I can mark those as done. That's done. Okay, 2, not connected. 3, not connected. 4, not connected. 5, not connected. 6, nope. 7, tied high, we did that. 8 is ground, so I'll just put that there. 9 is the input to the actual only thing that's doing anything over here. 10 output to that, 11 output to that. 12 is the ground for output enable. 13 garbage output, 14 garbage output, 15 unused input tied to high. Okay, so I think I'm gonna sprinkle around. Boom, 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 boom. Bunch of no connects. So over here, I'm gonna grab, makes sense, there's only one transmit pair. Yeah, that is exactly what I'm thinking. So I'm gonna put that, and that, and that, and that, connections. Okay, needs 4 connections. Power ground data's right, yeah. Output okay. Power output enable, data in, 2 data out. So you're saying 4 signal connections, and we have 1 here. There's output enable there, and then 2 outputs. 4 is input. What do you mean 4 is input? 1, 2, 3, 4. 4 is enable, but I think it's enable active high. We have the 7. So like we did down here for the 32, we only tied. We tied where is it? Something high. Why did we tie it high? No, we tied it to, that's the clock. Oh, that's the enable clock. So we did that. So 12 was this one, the clock, output enable. 4 is another output enable. But if we have the inverted output enabled connected, which we do right here, do we still need 4 to be connected? Or would 4 connect to ground? Because I don't think it would connect to ground. I think it would connect high, right? Which would mean it would need to cross over, which would mean there would be a via that we could see. Pin 4 can be ground, but 12 will rule. So both can be ground. Oh, that's complicated. So they can both be ground, and this one can just chill right here. Okay. That scares me, because I'll have to cut a trace if not, but that wouldn't be too bad. We can do that. I will mark that one as ground, probably. Data sheet, page 9, okay. Not that. This is 32. This is 31. Wherever that is. 31. Page 9. Let's look at this. Boom. That was the wrong page. Up to. Okay. Application diagram. Okay. Oh. Complementary output out. If you're using G and logic input, setting either G to a logic high or G to a logic low enables the transmitter. If G is set to a logic low, G is set to logic high, transmitter outputs. Okay, so you're saying that's an OR gate, is what it is. So OR gate, either one could do it. Oh, a table, okay. Doesn't matter, okay. Got it. Okay, so it can be grounded, but okay, it just means it can't be floating. I see what you mean. Okay, grounded. Okay, so we have 10 and 11 go off to nonsense. It'll be plus and minus, but it's got some passives. Actually missed both. Oh, okay. Ignoring Minjeko Tech, no problem. Oh my gosh, only 19 more minutes, seriously? We're not going to finish this in that because this thing's stupid. Dang it. All right, let's do this. Top pins. Let's label these. LS32 also needs pin 4 fixed. Okay, we can do that. So that'd be this one. And that's ground, I assume, that it goes to. That would also make sense. We can do that. Now I changed my color, so drat. Yellow. I'm on the wrong layer, which was good to know because it was about to not let me type stuff onto there. Okay, there we go. Pin 4, can I, yep, steal the ground. Boom. Ramp. Ramp. Okay. Save that. Save that. Alrighty. I'm gonna go ahead and lock this in as a good step here. Do I have a folder somewhere? I do not. Why do I not have this open? Oh, there it is. Okay. So git commit -am all but buffer index. Oh, hold on. Let's do this. We have a very tremendously satisfying rectangle to make. Boom. Yeah. All right. Save. Save all the things. Yes. Save and then push. So if my laptop explodes, then I can keep working on this at home maybe. All but buffer and external connector done. Git push. Boom. All right. Updates rejected because remote contains work that you... Uh-oh, that's true. Well, that's not good. What did I do at home? Uh-oh, I forgot to pull. Whatever I've got here is probably... Oh, in case of fire, git commission. Push delete build. I like that. 8 hours ago, X-ray layer names. That is the least important commit ever. Okay, how do I force a push and disregard? I need to do that. Force push. All I did was rename, now I'm remembering, all I did was rename some layers down there. Force push git. Okay. Do. Just dash force? Okay, let's just do that. Dash force. Hey. Should have a -A there. Just so that it catches everything. Does commit automatically capture everything? I don't think it does. I think it only does what's staged by default. I think I'm gonna have timed out the water perfectly. I wouldn't mind a little more probably by the end of the stream, but not totally required. Wow, this is taking forever. Just double check that my file here hasn't gotten over 100. Ooh, nope, it's only 53. Excellent. Never used Git? Ah, okay. It's a little weird for something like this, but it does work fairly well. Like I mentioned earlier in the stream, since the schematic files are just text, it can revision control it fairly well. KiCad does also just save the zips, so you can just revert by just opening the folder and going back. At least I think this version does. I don't remember 5 doing this. This is kind of really handy. I love how stupidly blunt this solution is. Because it's just, it will work. So I love Git, but hate its documentation. I've had some problems with it, but I haven't had that many overall. I've even run my own Git server. So it really just depends on what you're trying to do, I'd say. I guess I can start changing files because it doesn't push anything from the working directory. All right, well, I can definitely feel more confident about what these traces are over here doing. So, if you remember initially, I had no idea what one of these was doing that went from somewhere crazy, but now I should actually know where they're going because I know what all the signals are. So that's pretty sweet. Yeah, that was why I was going to label this. So let's work on that. Let's label the connector. I'm going to bring this up. You know, I'm going to open that in GwenV so I can have it on another monitor. I'm going to put that over here. Oh, you know what? I guess I could also just look at this. You know what? Let's just do that. That makes, like, more sense because it's the same. And then I don't need the dumb, broken text editor. All right. Or do I even need the... you know, it'd be nice to have it in both places. Let's just do it. Okay. So, here... and then, you know what, I'm going to make this a color that's really easy to see, actually. Let's do... cyan, I guess. I don't know. It's really hard picking, like, visually distinct colors for this over and over. That's a little big. Maybe let's make that smaller, I think. Boom. Let's change the kerning. Boom. That's... oh, that wasn't kerning. That was line spacing. I will be changing that for sure. Okay. So there's that now. We're going to have to make that smaller. Perfect. Okay, so that first one, response plus response. Ooh, that's not. Oh, that's right. Response minus. Okay. Minus. Okay, it's time to do some other stuff. Command. Actually, can I just... no, that's not a one text field. Plus command minus. All right, let's change the line spacing slightly here. Dockable dialogues are a mistake sometimes. Not font size, line spacing. There, that'll do it. Okay. No, it won't. That's way off. There we go. That color's awful. Black is not very good either. You know what? Just red. Okay, the red doesn't work because there's red circuit board. Green, I guess. I don't like the green on the white. There's no good colors. Yellow's the most visible. We'll go with that. Orange? Yeah, I've been thinking about trying to integrate orange. It's just kind of Yeah, see, that's so close to red, this area becomes really hard to read. That's way easier to see. We're not going to have yellow... oh, we are going to have yellow traces. That's right, they're all going to be yellow traces. Alright. I'll go back to cyan. Maybe a light blue. Like that. That stands out on the red, at least. Alright, we'll go with that for now. Okay, command plus, data plus, that was an underscore, data plus, data, minus, data, clock, plus, data, clock, minus, and I think I need to adjust these again. I'll do a font size reduction. Nope, too late. Can't do that. I can do that. Where is that right? Hold on. There we go. Yeah, I know. I just want them like really obviously done because I'm an idiot. I want to make sure that they're super painfully obvious. I know what these M1, 2, 3, 4 things are. What was that? Oh, maintenance. That's right. They're probably not connected to anything, except for that one that is. I don't like that. M1, M2, M3, M4, and G&D. Okay. Labels. All right, let's disable editing on that. Save factory test stuff. Yeah, except for that one. Maybe it's just a test point that they want for something. I think it's just grounded. Yeah, that's just a test point. Okay, so that's kind of not necessary. It's funny they shipped with the resistors on there, but all right. Okay, now that we have that, these ones up here. So things going to, excuse me, this, that goes to 2. 2 is command, and that totally makes sense. Command minus, command plus. Okay, so we can say that those go there, and they don't have resistors on them. That's weird. So, all right. We can just grab, yoink. M3 needs to be ground for normal use, high for factory test mode. Ooh, that's exciting. All right. I don't know what we do with factory test mode, other than probably break something. You know what? I need to check this. I'm guessing top is minus. Hold on, command minus goes to 11. Yes, so I need to rotate those. Which works out because I kind of wanted to do that because I'm lazy. Boom. Our first buffer has been connected. I don't know why it doesn't have any resistors or anything. I don't like that, but you know what? I won't question it too much because that means I don't have to do more work. All right. This and that. And now we can continue with the labeling. Boom, 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 boom. Why is it not drawing lines? Hold on, there we are. Look inside one of my bins, random computer stuff, realize I have a motherboard for Sinclair QL. Ah, cool. Okay, boom. Oh, nope, still not drawing anything. What time is it? Oh, 5 minutes? Gross. Resistors are on the receiver side. Ah, that makes sense. Okay, so there. Now switch to yellow. Boom, boom. All right. This one. Boom, 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 boom. Oh, man. This is going to be so nice having this stuff, like, actually figured out. Holy moly. I'm probably going to have to finish this up tonight. All right, how far do you guys want me to go with PCB stuff off stream? Because there's some of it that's going to be really boring. Like, maybe I can do all the footprint stuff off stream, and then we'll actually do traces, because that way I can start, and it'll be like what you would think I would actually start with. Because the reality of making PCBs is that you probably spend 75% of your time doing footprints. So maybe tonight I will work on footprints for all the parts, so that we can just hit the ground running on traces tomorrow. So I'll have all of like the components laid out on the PCB page, stream the 4 receiver stuff. Yeah, I think I can do that. I think I can, but we don't have like a tremendous... I'm just saying, like, even if I don't get this done in the stream right now, it's just going to be not that... It's not going to be that much that you're going to miss, so... that chip's done, by the way. We can mark that chip done. So let's just do that real quick like here. Boom. Boom. Done. So basic footprint are already in the library. They should be, yeah, but I got to go and connect everything, and then I'll want to do stuff like make the test points and all that. So, yeah. And then I'll want to try and find like mounting tabs. I won't make this bracket, unfortunately. That kind of sucks. But, you know, that'll work. But that's cool, Ben's Lab. All right, let's work on some of this. So... all right. How many of these? Okay, hold on. I bet we can really fast track some of this. So let's go pin 9. What is 9? 9 is a minus level output. Let's look at where this goes, because I bet we can just like put resistors for all of the lows to ground and all the highs to 5 volts. If you want to not have 100% accurate card, you can use ready-made DB15 brackets. Ooh, that sounds appealing, but no. I want the PCB to be as accurate as possible. What I'm kind of hoping here, actually, is that I'm going to be able to steal a sound card bracket, because that's where a game port usually is. And then I'll just have holes in it, because I got, like, tons of garbage Vibrus type stuff. So I'm hoping I can get a sound card bracket and put it on there. It would be PCI and it would mount on the wrong side, but I can just not mount the tabs and only screw it in and it'll probably work. So that's what I'm thinking. Because that's just game port, really. So, okay, 9 is... Let's do this, boom. Okay, so 9, there, to there, to there, to here. To that, to here, to resistor, which goes to the other resistor, which goes to this, that's a test point. Oh, bus, ground, okay, ground. Minuses go to ground, okay. So, add R, this, ooh, I'm gonna wanna space these out a lot more. Ground. Boom. All right. Let me stagger these a bunch. All right, so then I bet 10 goes to a resistor that's tied high. Boom, boom, boom. Just right there. Okay, and no, that one's tied low too. What? That also goes to ground. Then why are any tied high? Are any tied high? Are all of them grounded? That one's tied high. What does that go to? That also goes to 10. What? Is it a voltage divider? Hold on, that definitely goes to ground. Ooh, that would be nice. Oh, those would be super nice. Those are awesome. Yeah, that would be great. It might even be worth just making it fit something like that. Well, that's a 15 pin though. Ooh, I don't know. Wait, these are 15 pin. Yeah, I don't know. I'll look at my options. Would you think that this would be a voltage divider? Because we have very definitely same trace going here, goes through those. One of these goes to ground. No, the 5 volts down there, and then the other one goes to ground up here. So why are they lowering the voltage? Also, how would that work with a signal? I don't understand. Would this be... Yeah, simple level shifter, that's what I'm thinking, but now would this be open collector? Is that what the term is? So it would actually pull it down to make a signal? I don't like this. I don't understand it. How does that work? Well, for the record, this just goes here to there for response, which is pin 1, maybe? I don't know. Oh, with one in the middle. Let me look and see if there is one that makes sense that's in the middle. That'd be a super weird thing, too. Like, what on earth is that? Profibus cable? Profibius cable? Whatever the name that is. That's super weird. RX, ugh, gross. Okay, let me see if there's one in the middle. No, I don't think there's one in the middle. Unless it's on the other end. That would be dumb. That is RS485, like RS422 we have here. But I don't see one in the middle. It kind of just goes off. So we have response minus here. So I can... And that's what I was kind of going to. So it's like this goes to right there, to right there, to there, to there. But these don't connect with a resistor anywhere as far as I can tell. But this one gets divided. Well, alright, I'm just going to mark it down. We'll see how it goes. Top resistor via under the chip. Yeah, so it goes to this ground right there that runs under the chips. So it'll be like that. And, oh, that's annoying. Put it like that. And then it seems like they actually directly connect. Like the resistor is actually just used to pull them high or low. It's not they're not in between the signals. So we can actually just name the traces directly coming out of the diff things, buffers. So that's response plus minus. So this is reverse engineering the board? Yes. So the whole point here is at the end of this, we're going to have a board. Well, right now we're just trying to make a schematic. And then after we have the schematic, we can actually make our own PCB using what we learned about the schematic. So that's the objective. So there's that, and then I'm guessing all of these are the same. So, you know, I'm going to mark a line through those resistors. Wait, why is that? Yeah, 3. Why? Because I need this card. I cannot buy this card. They're too rare. So I have to make one out of these pictures that I've got so that I can get one produced. So that I can assemble it and then hopefully use the first CD drive that's ever been made. Because I have that CD drive, but I don't have the card that makes it work. All right, so let's look at another one. So that was a plus. So this plus here for data goes to that, which is then split, and yep, high-low. So, all right, here's what I'm going to do. I'm going to copy the whole resistor shenanigans, and I want to put that on every single one of them because they're all the same. Boom. And boom. You know what? I don't need that over there. I can go right there. All right, why no pull-up on the plus line? I don't know. You mean the minus line? Wait, hold on. What's the deal with that? Wait, are these backwards? 10. 10. Oh, yeah, that is backwards. Hold on. That might have been slightly bad if I did that. Wait, is that like permanently connected to that trace? Whoa, how have I never had that happen before? What? That's awesome. So if I put that there and now I move, whoa, dude, that rocks. Yeah, I don't know why there isn't one on there. So here is the minus, all right? So response minus goes here, it goes to this resistor, and then that's it. It doesn't, oh wait, does it go to that? No, it doesn't, because that's, yeah, so it goes to there, and then that goes to a test point, and then it doesn't go anywhere else. Other than, no, that's a scratch. We determined that's a scratch. We've looked at that like 3 times now and said, oh no, something's bad, and oh wait, no, it's just a scratch. But it doesn't go to any other resistors. Yeah, it's just a pull down. So I will check, let's check 7 here. So 8, 7. All right, 7 goes down through, does 7 even have a resistor? Wait a minute. Seven just goes straight into the connector. Does that mean it comes back out? Oh, that's super gross. Oh, that's horrible. Okay, let's not do 7. Let's check 14. That would be this one. So it goes down here. Probably under that, doesn't touch anything. We don't, like, maybe it probably goes to that. Oh no, where is it? Uh-oh. Goes to those, okay. It does seem like they all connect to 2. Where is the one for 9? That doesn't make sense. 9. Wait, no. 9. $14 to pin 5. What? 14 to pin 5. Well, yeah, I see where it goes over there. That's, you mean on the connector? That's not a problem. Those are, we kind of don't even have to try to those. Those are already figured out, basically, because we know what the pinout is up here. We know what they go to down here. So realistically, that's kind of solved already. The problem is that I don't know where the other resistor is for this one, because it's not that. Goes down to that, to there. How many resistors do we have? I mean, could they have forgot one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12. There's 1, 2, 3, 4, 5 signals. The M2 one down here goes into 1. So that consumes one of them. Where is it? Yeah, so maybe they forgot to put one on there. So that would leave 11. Oh, that's still too many, though. 11 resistors for 4 pairs. Yeah. That doesn't make sense. That divides really, really poorly. Yeah, I think what I'm going to do here is we're going to call it. I'm going to go home and I'm going to figure this out because this is going to be dumb. Because I'm just going to be drawing over the traces and figuring out what everything's going on because this is weird. We basically already know the pinout. So, like, here's what I can do. 1 goes to response. 2 goes to command. 3 goes to this one. So we can say that's data. So we can just come down here and grab these. Data, not the line. Deselect the line, copy, paste. All right. So data. Boom, done. 4 goes to data clock. So we can say that's clock. Data clock. You have it connected to A0 at the UART. One moment. I have what now? UART. 1 is wrong. 1? What do you mean? It's connected to CD? And then it runs down to A0. That's what you said that would make sense. So it goes from A0 to the command data signal, which goes to response on there. I think that was response, yeah. A0 to the UART makes sense, but not to here. So does that connection not make sense? Because that will be problematic. Now, I'm going to put the last one on there for attention, because it's attention. I don't know how I coincidentally ended up having these all kind of line up here. But that's how that worked. Oh, I did it intentionally because I had the traces routed pretty. I will be double checking all of that when I lay out the PCB, so, you know, we'll make sure. But yeah, I got to figure out the resistors. That's going to be dumb. So This is going to take a while longer. It just doesn't feel right. That pin wand. Well, we'll figure it out. We'll take a look at it tomorrow before we start the PCB. So I will mark that as not sure, and we'll take a look at it. Because I kind of need to end this. Do some other stuff, take a break, go home. I'll figure out the dumb resistor nonsense. There's just a lot of idiocy going on right there, I think. I don't know. I'll figure it out. So let me head over there and wrap this up. Oh. We really need to end this project because this is taking too long. I know there's some of you who are appreciating this and like the background noise and that kind of stuff, but viewership is about half of what it has been on average every time I come over here and look. So yeah, these are not exciting streams, and I know that. So we need to get this done. So like I said, I'm going to be working on a bunch of this at home again tonight. I will do up to all of the footprints being on the PCB page, and linking to all the parts and all that stuff. We will double check everything before we start running traces. So yeah, A0 is output and response is also output. Yes, so that goes in line with how it's set up though. So I don't know. We'll double check it though. And then like I said, as we route all the traces, we'll have like a built-in sanity check for everything, because it has to physically line up with the existing traces on the board, because I'm going to try and clone the board as close as I can. I'm not just going to drop in the rat's nest and let it auto route. That's not how it's going to work. So yeah, we will 2 outputs is short circuit. Well, wait, no, let me go look at it. Now I think I might agree with you. Hold on. No, it's, yeah, you're right, that doesn't make any sense. Great. All right, well, we got to fix that. I might fix that tonight. I don't know. I'll take a look at it. I'll try and figure that one out. That's wrong. Okay, let me... gross. Yep. Nope, that's bad. Okay. KiCad doesn't even have it auto route since it's terrible. You have to pay big bucks for it. There's open source auto route plugins that you can get, but I'm just saying I wouldn't do that. I don't think I've ever actually auto routed a board anyway. I always manually route them because you end up with something much more sensible. Anyway, that is it for now. Lots of work still left to be done. Stupid problems to solve. I gotta figure out what the response pin is connected to. If one of those brackets fit within a few millimeters, yeah, I would do that, Helencroft, that's for sure. But since the connector is like shifted all the way here, I'm just gonna go really quick. I'm gonna go grab like a cheap vibra or something just to see, because I have a really strong feeling that the connector is basically the same as a sound card. Yeah, here we go. So that one's low. Oh, that's not good. That one's low. That one's low. Ooh, that's not good. I already have a bracket. That one. That bracket, it's ISA, so it mounts on the correct side. Guess what? I have a connector too. No, I will buy the connector, but I might reuse the bracket. So yeah, that lines up pretty much exactly the same as the other one by eyeballing it. So probably gonna do that. I will check the offsets, but I bet I'm gonna use that bracket. Since I'm probably the only person who's gonna make one of these, I'm not too worried about it, but I might recommend it as an option, so yeah. So let's see, regular YouTube viewer here, caught your last 3 mailbag videos. Congrats on getting that 20th anniversary, Mac. Thank you. And also, hello, JFD62780, since it's your first time chatting. We are ending the stream, though. We've been live for 4-ish hours, so yeah, that's enough for now. Like I said, still plenty of work to do. I will try and chase down some of those errors, finish up the schematic with the resistor things. We basically have the schematic done at this point. We just have to do the error corrections, and then finish up the resistor stuff. We really, realistically, know how the board works at this point. So we're pretty close. There's just the last little bits that are frustrating. So this was a very, very productive stream. I was really hoping to get to PCB today, but yeah, wasn't in the cards. So excuse me. That is it for now. So I'm gonna run the outro. All right. See, also this is on part of the regular vid. Sorry I missed the stream. Glad to be here. Well, thank you. You can check out lots of these actually on the second channel. So yeah, I'll say that. So there are actually currently 21 streams scheduled to release every single day, I think. It might be 22, I don't know. This one's gonna be up there soon. So yeah, that's pretty much it for now. If you enjoyed this stream, you might want to subscribe on my second YouTube channel where I upload all of the VODs. Or if you want to see more structured stuff, you can subscribe to my main YouTube channel. That's probably the better one, you know, of the two. But anyway, or you can follow me on Twitch where I do these videos live. If you want to help support the channel, you can subscribe on Twitch, which you can do with free with Amazon Prime, or you can buy a t-shirt like this one. Yeah, or Patreon, that's the other thing. Anyway, that's it for now. Massively appreciate the help from those of you who have been, especially Hello Croft. Thank you so much for being a second set of eyes on this. I really, really appreciate it. That pin 1 output thing, I'm gonna have to figure out what that fully connects to. That's a very good catch. So, yep, we'll see you tomorrow. Hopefully to start on the PCB, but we will be going over the schematic one more time before we really start on the PCB, just to make sure everything makes sense. So, yep, that is it though. So I will see you next time.